All right, so we've gotten pretty far with our application and the different things that we can do here. And now again, we're going to take a detour, start looking at other things. And the first new subject that we're going to look at is going to be writing tests. Now, currently when we've been developing, really how we've been doing it is if we've been opening up our fast API docs and we've just kind of been trying it out there, which, is kind of fine, but it's not ideal. But at least, it allows us to try things out and stuff like that. And we were able to catch some errors. But obviously, this is not really something that's scalable. And more importantly, if we were to add new features or change existing ones, we can't redo this whole process every single time. And so instead, what we want to have is just some way that we can automate our tests. And yeah, that's what we're going to look at now. We're going to look at how we can write tests that we can just run every single time. And so that way we know when we make changes that if we run our tests, then everything that has been working a certain way previously should continue to work that way. That means we're not introducing new bugs into things that have been working before. Now to do this, we're going to install PyTest. So we're going to go out of our virtual environment. I already am. I'm going to go pipenv install PyTest like this. Hit run. Oh, actually, I just realized we should be installing this in the dev environment. So I'll let this finish and then I'll uninstall it again. So pipenv uninstall PyTest, because what we want is we don't want it here. We want it in our dev package. And I actually just saw that MyPy should also not be here. It should also be in our dev package. So let's move that over too to make sure that pipenv uninstall, that all of that is in the right location. So I'll just finish with this installation process here. Again, these dev packages, we want them here so that we're running our application in production. We're not unnecessarily installing libraries here that we only need for testing purposes. So we're going to pipenv install dev mypy, which we just uninstalled, and pytest to make sure that they properly get put in here. Okay, so let's see, open it back up. All right, there we go. All right, so let's go back into our virtual environment. And now we should have a command called pytest available on our command line or our terminal here. We'll see how to use that in just a second. So now what I'm going to do is I'm going to create a new folder on our top level here, and I'm going to call this tests, like this. And in here, I'm going to be adding all of my tests. So now you may be wondering, okay, so what should we test and how should we test it? Well, let's start with the lower level things. So we start off with our routes. And our routes actually use this user service, and then we call methods in our user service. So it would be good to go all the way down where there's no other dependencies, because if we run a test for this thing here, then essentially we're also testing everything within. And if one of those things is not working, then we're really trying to test, let's say there were 3 steps here, and if step 2 wasn't working, then it's not this thing that isn't working, but actually it's step 2 that's not working that needs to be fixed. So we want to start at the lowest level and assure those are working and then kind of work our way up. Yeah. So we're going to go to our user service, which is actually here in the service directory. We'll go in here, and here again we have a lot of different methods that we can test. So let's start with some of the lower level ones. So one of them that we have here is going to be this one here. And let's see, this one also looks to be, doesn't use anything else, as does this one. And this one calls our get user info. So we wouldn't want to start with this one because obviously it wouldn't be ideal because with this we would also be testing this, and we haven't tested this yet. So let's just start at the very, very bottom, which is going to be delete users. All right, so we're going to go in here, and now we're going to create a new file that we're going to call test user service. since we may have many different things here, we're just going to be specific about what exactly we're testing. So we're going to be testing this file here, like this. Now it's important, it's generally good to put the test underscore here, although you don't necessarily need it, but it's kind of important in the sense of like readability. And this test here again is just for like readability to make sure that everything is organized in the right places, and also later on when we start using other things like Docker, then again, we don't want to move these things into production when we don't actually need them. So we want to be able to easily separate them out. All right, so let's start writing our first test. And actually, we're going to start with something extremely simple just to show how this works. So our first test is going to be here for users, and it's going to be for this delete users. But before we do that, let's just see the most basic tests and how it would work. Let's say we want to test, I'll call it test true, and you'll see why. We just want this to always be true. How can we do that? So two things that are very important with PyTest. The first thing is for PyTest to find a test that it will run, and you'll see what that means in a second, it has to have this test prefix here. And we'll see what happens when we take it away in a second. So we need to have this test prefix. And then in here, generally what we want to do when we have tests is we want to use this assert statement. Now this assert statement will evaluate an expression within that will return a Boolean value, and if that expression evaluates to true, then the test will pass. Otherwise it will fail. So true always evaluates to true, obviously, and so it will always pass. So let's see how we can run this. We're going to do this by going pytest, and then we're going to reference our test directory, and we're just going to say /star, which means run everything in here. So all files and folders essentially referencing everything. And pytest will kind of iteratively go through all of this, like this. And so we can see here, we ran one test in the test directory. This is the file. In here, this is essentially the result, and we can see here, green dot means it passed. One test passed in 0.04 seconds. Alternatively, right now we could also run it like this. But it's nicer to use the syntax because maybe you have other directories in here, and sometimes you may need to add, an extra folder in here like this. Okay, yeah. So this is good, but there are actually ways that we can also increase our verbosity. So let's have another test here that we're going to call test false. And this one is always going to fail, like this. So we're going to run our test here, and now we're going to see here we have one test failed. And the nice thing is it actually tells us, so we can see here this green dot means it passed, this red F means it failed. So it's actually going to tell us for each of the tests where the problem was. In this case, obviously it's very simple, but let's have a very more simple or a little bit less simple, but still very simple example. We're going to have two variables, call them A and B, and here we're just going to test that A and B are equal to each other. And so we can see here, in this case, we're checking, and we can also click on here, which will bring us right to this line. We're checking this assertion, and it's actually giving us these values too, asserting that A is equal to B, which is not the case. And so, again, we can also see the output here, that this is not working properly. And there are some nice flags that we can use here. So essentially, we can put something like -v, and we'll see in a second we can do more of this, which will just increase the verbosity. So right now nothing has changed because that's kind of the one we start with. If we do $V, then, well, we can see scrolling up that we've gotten a little bit more information here, but essentially we can add more V's here, which will increase the verbosity of our output. In this case, not really much is going on because we've kind of reached the limit since everything is so simple, but just think about that. Sometimes when you need more information, maybe just adding an extra V flag here will do the trick. Generally, I will use V because I like it more. It's nicer to have this sort of summary than it is to just have these green dots and red Fs. I think this is a lot clearer for me to get a very quick overview of what's going on. All right, another thing that we have is if we have print statements here in test false, and here we'll have in test true. If we run this, we'll actually also see the output of the tests that are failing, but not of the tests that are passing. So this is, again, something really nice that can help you with debugging, because sometimes, a test will pass and you're like, why? Why is this value here? And then you can add print statements, for example, to just kind of follow everything along and understand really what's going on. So yeah, this is the very, very basics of tests. Now, if we remove this test prefix and I try to run this, all of a sudden it will no longer be captured by PyTest as a test that it needs to run. And so we'll see we only actually have one test that's being run, like this. So that's why it's important to have this test prefix in front. And taking away this underscore still works, but again, for readability's sake, we want to have this underscore here, because otherwise, this is coming back to our function naming and our variable naming. So yeah, that's that on the general structure of tests. Again, two very, very simple ones here, but this is essentially how we're going to start approaching tests. And obviously what that will mean for our user service is we're going to test each of these things and just make sure that certain conditions hold after we've performed certain operations. And generally we want to provide input conditions and then test certain output conditions. Now obviously, even with writing tests, we are the ones that write it. And so that's just because we have tests doesn't mean our program will be bug free, because there are many cases, like edge cases, that we may forget to test. And so if we forget to test, then we will never see our tests failing in those cases. And that bug will go through until someone finds it. And generally, what is a good thing to do at that point is if you ever find a bug or a bug is ever reported for your program, what you want to do is you first want to write a test that reproduces that bug. So you want to write the test and then just get it to fail. And then once you have that test, then you can go ahead and fix it, and then you can run your tests again and make sure they're passing. Now, this is really nice because obviously, for one, you're able to reproduce the problem, which is very, very important to be able to properly fix it. And when the test is passing, you can feel pretty good that things are fixed. But also, this means that now this extra edge case has been added to your tests, and if things are ever changed in the future that will actually break this again, then your tests will fail, and this error will never go out again. And so, as you develop your application, and even as you start and you write your first set of tests, but then as it grows and you add more and more and more tests, it becomes really nice, because releasing your application is not going to be something that you do with fear, hoping that things are going to be working properly, but rather when you've added your tests, you can feel pretty confident that things are probably working as expected, or at least the general behavior. Maybe there are some edge cases that you forgot to think of, and maybe it's not completely bug-free, but at least the general behavior should be working pretty well, and you can feel good about it, and you don't have to go to bed extremely worried. And also, when you're making changes, especially to a large project, then you can run the test and you can make sure that everything is still working as expected, so that when you add your changes and they go live, other things that used to work are not breaking. So it also really helps with just providing peace of mind. And yeah, generally tests are just a very nice thing for everyone. So now that we've seen some example tests and how they work, let's go ahead and actually add the testing of our user service here. So we're going to start very simple and then just kind of expand with this. Okay, so first of all, I'm going to take all of this out, and we actually have to add an init file here, but I'll show you what happens if we don't. So to start out with, I'm going to say from app.services.user, I want to import. And right now, when we do, for example, like getting user info, creating, updating, deleting, all this good stuff, we're also using these things right now because, again, we don't have any database connections. So I actually also just want to import them for now for this purpose. Although, generally, as we'll also learn about databases later on and stuff like that, all of this will fall away. But since this is the current structure of our application, this is the way we have to test it. So I'm going to import profile infos, user content, and user services. Profile infos, user content, and user services, like this. All right, I'm going to write my first test, which is going to be, let's see what we have here. Let's say we want to start testing delete. So we're going to say delete user works properly. All right, and what we're going to do for now is we're going to create a new variable that we're going to call user service. Oh my god, service. We're going to initialize the user service like this. Okay, and essentially now what we want to do is we want to go into our user service here. We want to say delete user and then our user ID. Now there are some things that we're doing here which will change later. For example, generally we're not going to be defining this here, but we'll define it somewhere else and then reuse it. But again, one step at a time. One thing that we are going to do though is this user that we're going to delete. Ideally, I would prefer to have these be variables. That way it's easier to reuse. So let's say user to delete. We'll have this be, well, not 9, 0. Okay, like this. So now we're going to delete this, and now what we're going to do is we want to assert that that this user to delete is not in this dictionary, and we also want to assert that this key is not in our user's content, like this, right? Because those are the two places that it should be deleted from. All right, so several things wrong with this, but let's just run this for now, and then we'll fix them as they come up. So try to run the tests. First thing it's going to complain is that it actually can't find the module named app. This is where we're going to add the init file here, which is going to register this here as a module, and which will let it access all the other good stuff that it needs. We can see here. All right, so we still have some errors. So reading through this, we can see here, okay, so we've got some assertion errors. Essentially, assert 0 is not in, and it's still in here, so it didn't work. Why? So let's look at, how can we actually understand this output? So we see here we have the summary of our tests, and we can see here in both of these, and this is actually the same place, we've encountered some assertion errors. The error is that 0 this is what we're looking for, but this is actually not true. So this is false. So this is our first test here. Or actually, this is our only test. But we can see here we're encountering several errors. So we can see here the test name. And here's the first error that we're encountering, which is the first assert statement here. And we can click on it and it'll bring us right there. Again, in the same function, this is, oh no, this is the same error again still. So, oh yeah, and I never actually got to the second point. So we're looking at the same thing here twice. But okay, so what exactly is going on here? Well, if we continue to scroll down, we can actually get a hint at this. It says the coroutine user service.delete user was never awaited. So this problem here is that actually our delete user here is an async function, or it's a coroutine. And so if we remember, to run coroutines, we actually have to await a coroutine. Now, we're going to run into some issues here, because if we add an await here, then if we remember from coroutines, to have an await statement inside a function, it actually needs to be an async function, so it needs to be a coroutine in and of itself. But if we try to run this, we're going to run into another problem, which is that to run this, we actually need to start this thing called an event loop. Now again, we're not going to go too much into async because there's a completely different of course, about all of that, that goes into this in more detail. But essentially, for Fast API, Uvicorn took care of this process for us. We used async functions there. It started this event loop for us. And whenever a coroutine is awaited, it essentially gets added to this event loop and handled properly based on if it's currently running or, waiting for some outside response. But with PyTest, this is not the case. And actually what we need is we need some sort of async capabilities. And we can already see here, it does give us some hints as to maybe what we need to have to handle some of this stuff. So what we're going to do to get this to work is I'm going to deactivate my virtual environment. I'm going to do pipenv install dev pytest async IO. And this is going to allow us to add async capabilities to our tests. So we're going to install that as a dev dependency, which should add it as a dev package here. Perfect. Okay. Going back to our tests here. We'll wait for this to finish installing. Okay, we're going to go back into our virtual environment. Excellent. And now we're going to import PyTest here, and we're going to use a decorator. We're going to say pytest.mark.async.io, like this. And now this is going to mark our test here to be an asynchronous test, which PyTest will now properly run and handle. So with this, we're now able to run asynchronous tests. So, that's not what I want at all. Let's try that again. We're going to do pytest tests star. All right, so we've actually run into a little bit of a strange error here, which is our tests are running twice, which we can see by adding this /vv flag. We scroll up, see it's running our tests twice here. Now, technically, this shouldn't even necessarily be a problem with us if our thing was set up correctly, but since we're using these global variables here that are being updated and not necessarily being reused, which is a problem both with our test setup, which comes through how we set up our repository, this is causing issues for us. However, if we do want to get this test to pass, all that we have to do is remove this /star for now. So we can see we're only running it once now, or we can also specify the exact file that we want to run. I'm not sure if this is due to an actual bug in PyTest or if there's something else going on, but regardless, for now, we're just going to not worry about that too much. And instead, we're just going to fix our code so that it shouldn't even matter. So yeah, what's going on? So yeah, right now we still have these global variables here. And the first thing that we're going to do is we're actually going to change this up a little bit, and we're going to pass them as initialization parameters. And essentially what we're doing here is we want to have our whole code system be set up in such a way that we can, define everything and all of its dependencies with initialization parameters. And that way, when we have tests, we can input, test values instead. And if we have, different images like production images or maybe a dev image or different ways that we want to run it, all of these things can be defined as we create the application. So there's nothing that's predefined that will be causing issues like this for us. So we're going to just add in here the profile infos. And we're also going to be adding the user content here. For typing, we'll just, for now, just say it's a dictionary, because we're not going to we don't want to do like too much typing here because we're going to remove this anyway. So again, this is all just for kind of testing. And we'll create these as attributes of the property. Now, obviously, this could cause some other issues, since essentially we want these things to be shared if we have multiple of these things running. But really, in an application, when we're starting this up, we're only going to have one user service, and if we need to reuse it, we'll pass an initialized version down. But at the end of the day, like, all of this is just placeholder stuff, and we'll be using a database later on anyway as a replacement, which will fix all of our problems for us. So now what we have to do is wherever we reference these profile infos, we instead need to replace it with a self-reference like this, because it's not part of the class attribute. These are no longer going to be static methods, because now they actually require the class the class instance itself. So we now do depend on the attributes, so we're no longer going to use the static method here. This also needs to be updated, and this is something we define here. All right, this also needs to be updated, like this. I'm going to remove these global flags here, and there we go. And let's see, this is something that we pass in. And here we should reference the self too. Also, this needs to be updated like this. These we can remove. And this we're going to add here like this. So let's just quickly go through this, see if we missed anything. This is looking good. We'll do the same thing for the user contents, the user's content. Also looking good. All right, so now we're providing these as input parameters. So now, now these are required. So now we should go up in higher levels. And where do we use our user service? It's going to be in our routes here. So now here we need to provide as input the profile infos as well as the user content. Now we can either define this here, or actually what I'm going to do is I'm going to provide this as input here, and I'm going to initialize this at the very, very top level. Again, because this is supposed to emulate our database, and so that's actually how I'm going to treat our database later on. So that means at the very top level, in our main here, when we're using this create user routes, again here we need to pass this profile infos and user content. So I'm going to go back down, I'm going to take these, cut, update the spacing to make it a little bit cleaner. So now we need to add them in here. For now, although this is not the cleanest approach, I'm just going to have a new function here called create profile infos and users content, or maybe get, actually create was probably correct because we are creating it. We're going to create this here, and then we're going to return them like this, and then we'll initialize them up here like this. Okay, so now we're initializing these at the very, very top, and then we're passing them down into our user service, and they're actually going to be added into our user service here, like this. Now let's quickly just start our application and make sure it actually starts properly. And I'm just going to, oops, didn't mean to do that. Just refresh our documentation. Seems to be running, and we'll just try one random thing out here. All right, so I'm not going to be too worried about this again. So generally seems to be working, which is good enough for me right now because, again, I want to focus on testing. All right, so we've done our refactor here. Now we don't need this anymore. Instead, what we need is we need to create these for us. So right now we're going to do this just in here. But in the next lesson, we'll look at how we can change all of this and make it a bit cleaner. But for now, to kind of finish this part of the lesson, I'm just going to copy this for now. And I'm going to put this in here like this. All right, so now if we run our tests, it's going to be like this. We are failing. Oh, of course, we need to provide them as initialization parameters here too. Let's try that again. All right, there we go. And now, even if we do encounter this bug, and if we run it twice, that's fine, because we're initializing our thing, and we're setting everything up within our test, and so all of this is going to be working properly. Okay, so we've done a lot of stuff here. Important things to note is that hopefully you can start to understand why we started structuring our whole system, this is not super pretty, but let's just ignore this, to use these factory patterns. So we have a create application, which means we can create an application if we have different configurations for local, for testing, for development, for production. All of these things are things that we can define, and we will get a different application with that. We are defining our user routes, which allows us to create or get these user routes. And again, here we can change things up, which makes it very easy to use in tests, for example. Similarly, for user services, we're providing all of the stuff that we need as input parameters. We can see previously the problem that we had by having them be global parameters here. And specifically, even if we wouldn't have run into this bug with the tests/star, we will still have problems going from test to test because we don't have control over these, because these are defined globally and all of them will kind of continue to go from test to test to test as they're being updated, which is again not nice. We're losing control over our tests. We no longer have perfect control over our input and output and making sure that the starting state and the ending state are, or specifically the starting state in this case, is well-defined and consistent, because as we add or remove tests, well, we don't really want to remove tests ever, but as we add tests, maybe we add tests, if we could further up, then our input state may actually change, which will cause further down tests to fail just because our input values here are not consistent. So for the sake of consistency and everything like that, having our whole program here in such a structure that we can create all of these using functions, and that anything that we need as dependencies here, we provide as input parameters here, which is called dependency injection. So any dependencies that we need, we will provide as initialization parameters, for example, to our class here. So this makes it really nice for just, obviously for running different types of the application, in this case also for being able to just properly test different features. So yeah, this was now taking the first step into actually writing the first test for one of the things that we've written. And then the next lesson, we're going to look at how we can clean this stuff up, make it a little bit more reusable, nicer, all that good stuff. All right, so now that we've written our first test, let's go ahead and clean some of this stuff up a little bit. So the first thing that we're going to do is, rather than defining these in here, we're actually going to define them separately and then essentially take them as input parameters, because chances are we're going to probably write a couple of tests and we don't want to repeat this every single time, right? First of all, this makes this test harder to read because we have a bunch of code here that is essentially just adding noise. So one reason, obviously, that we just want to remove this out, and another one is reusing this is not simple because now we just have to copy paste, which obviously we do not want to do. All right, so to do this, we're going to learn how to use PyTest fixtures, and fixtures are essentially input data that we can provide that can be created at specific intervals even, which is something that we'll look at throughout our application. So we're going to start with a very, very simple thing. We're just going to put this in the same file first. So I'm going to create one fixture is what it's called, and you'll see in a second what exactly that is. Here, that's going to create our profile infos data for us, and the other one is going to create our users content. So I'm going to create a function here called profiles infos. Now this here is going to be the name of the variable that I want. And then I'm going to put in here the value that I want to return. For example, like this, or I can even, because this is a function, I can define stuff inside, for example, like this, and then I can just return this, which I think is a little bit cleaner. So yeah, this is going to be our profile infos. And then also here we want to do the same thing for our users content, like this. And like that, and then we're going to return our values like this. And now we can actually take them as input parameters. Now the thing is, as they are right now, they're not ideal, right? Because they're functions, but we want them to be variables. And this is kind of where our PyTest fixtures come in. So we already have PyTest imported. So we're going to do a decorator here, and we're going to say pytest.fixture. And I'm going to take the parentheses out for now, but we'll also look at that in a second. And I'm going to put this here like this. And now what this is going to do is, when we take these as input parameters, it's essentially going to execute this function here for us, and it's going to give us this return value. So right now our profile infos is going to actually hold this value here that's being returned. And so if we just do PyTest tests and we run this, everything should still work as expected, because technically nothing should have changed. We just made this a little bit more reusable. So now we can write more tests, and oops, don't want that. And we can again take our input parameters here, and that's already really nice, right? But let's take a look a little bit more at these PyTest fixtures and what are the different things that we can do with them. So first of all, some people, there are different ways that you can organize this, and some people like to put the tests that are only required for this, this specific file here into actually the same file. I don't particularly like doing that much, just because it kind of clogs up your file, and usually you have your fixtures at the very top then, and then you'll need to scroll all the way down to see your tests. So what I prefer to do is, and we'll see other things too, is in those cases, I'm going to say create a new file that I'm going to call user fixtures.py, and I'm just going to cut this over here. I'm going to import PyTest. I'm just going to paste this here. So now we obviously need to import them, which we're going to do from here. We can say, for example, from tests.userFixtures, we can import our profile infos, or we can and our user contents. And once again, if we run this, everything should be just fine. Yep. Now another thing that we can do is we can actually use relative imports. So rather than defining the absolute path, because these are things that should be defined specifically for this function here, it's going to be on the same level. So no matter how many directories we're in, if we use a dot here, that means using the current layer. So currently we would be using everything within this tests, because that's where our test user service lies. So if we use a dot here, it's going to look within this current tests directory, and then it's going to start from here. So it's going to start in the tests, and then it's going to go into user fixtures, which in this case is a file here. But if it were a directory, then we could go further down, like with extra dots, like we know from the absolute path. So we could also use a relative path here if we wanted to. Again, things should be working fine. So these are the options if we want that. But generally, there are nicer ways that we can do this if we have fixtures that we want to reuse across, maybe multiple files or something like that. So anything that we want to reuse, we actually want to put in a special file that's called conftest.py, like this. And again, I'm going to take these user fixtures, and I'm going to cut this. I'm going to paste this over here. I'm actually going to delete this one now because we no longer need it. And just delete anyway. And right, should get rid of our imports here. Okay, now the cool thing about our conf test is that everything at this level or below will have access to what is defined within our conf test. So we don't even need to import it in here. Because this is in the same level, it will automatically have access. If we go one layer down, for example, some other directory here, we move this in here, and just leave that like this, and maybe we'll add, I already added an initialization file for us, perfect. So if we try this now it's going to fail because now it no longer has access to this. So we're going to move this back up like this. We're going to take this away. So there we go. So now this is really nice because here, again, we're just, well, this is something that we're going to replace in a second too, but for now, we can see here that just all of this here is already a lot cleaner because we're no longer defining a bunch of data that we're going to be reusing. Plus, we can use these variables now without actually even needing to import them, and they'll be reusable. All right. So now we're going to do, and let's just run this again to make sure our tests pass. All right, we're going to take a quick sidetrack right now, and we're going to take a little bit of a deeper look into these fixtures, and I'll show you some different things that you can do with them. So what I'm going to do is I'm going to create two more fixtures, or actually I'm going to create one fixture, and this is going to be our testing fixture, and all that this is going to do is it's going to print initializing fixture, and it's not going to return anything. I'll mark this as a pytest.fixture. And now we're going to create a new test here. It's going to just call this test_1 dot py. And in here, I'm going to create two more tests. So that's going to be test1, and nothing for now, and test2, and again, nothing for now. Okay, so what we're going to do in here is we're going to take our testing fixture as input, like this. And then we're going to look at actually how often these fixtures, fixtures here get created and how we can change that frequency and maybe why we would want to. So something that we can do if we want to is we can do pytest, then we're going to go into our tests. Here we're going to run test1 right now, just to keep it a little less output spammy here. And I'm going to actually add a -s flag, which is going to show us the output that we have here. So this is one option of doing it, which works. But personally, what I prefer to do actually is I'm going to just, for the purposes here, to see the output a little bit more clearly and organized, I'm going to assert false, which is going to make our tests fail. And then I'm going to use the double V flag like this. And we see here both of our tests fail, and now we can see our captured output. Personally, I prefer this because for me it's just a little bit more organized, but just know that you have that other option, that -s, which will also let you see the output. So what is going on? We have, going back to our fixture, we have our fixture here that we're creating. And whenever we're creating this, we're essentially printing out here initializing fixture. Maybe let's return A instead, just so that we can also, for example, do here print testing fixture like this, if we want to, just to have like a little bit more structure in our output. So going to our output, we can see here our standard out, we can see, okay, this is our output. We're printing testing fixture. In our setup, we're running this initializing fixture. So this is setting up for the test, which is what we print in here. And going up, we're printing the same thing here. So what this means is that every single test that we're running, we are recreating this. This is why we're seeing this print out every single time here. Because every single test that we're running, every single time we're using this in a test, if we were to not use this, then we wouldn't see this. So we can see here, there's, let's see, so yeah, this is for test 1. Yeah, so we can see it for test 1, but for test 2 we don't have it. And if we do use this, we can see now also for test 2, we also have this. So every single time we use this fixture, we are running this whole function here, which is really nice sometimes because in our case here, if we want to reuse this, we want to maybe recreate it from scratch every single time we use it to make sure we have the same input state. But in other cases, this is maybe not so nice because sometimes you actually want to have consistent state maybe within a specific sub area, or sometimes there are expensive operations. For example, if you create a database and you seed it with data, you don't want to recreate the database table and upload all the data every single test that you run. You want to do that once. So this is where scopes come in. And now we can add an option here. We're going to open close parentheses, and the default scope that we're using now is function. So that means every single function, this here is going to be run. So for every single function, we're going to run this, which is exactly the behavior that we have right now. We can see like this. But we can actually also change this. So the next level up that we can do is we can use a class scope. And this is going to be interesting because right now we've used it in functions here, but we can actually also define test classes. So for example, if we want to have a test class, we need to prefix this with the test keyword, just like we have for the functions. We're now going to do an uppercase test, and then here we'll have test example class. So this here is an important prefix. All of this here is just going to be the name. And we're going to indent this here. We're going to use our self keywords here because now these are part of the class. We're going to import PyTest, and then we're going to say use the decorator pytest.mark.use fixtures, and now we're going to provide the name of the fixture this class should use. So this testing fixture here. So this is the one that we are now using for this. And all right, so let's rerun this. And now we can see we have the initialization or the setup call once, but we no longer have it for our second test. If we were to have a test outside here, test 3, which is going to use our testing fixture, like this. Now again, we're going to have the output here, because this is no longer using it within the class scope. And now once we get into our class, the first time we use it in our class, we can see here we're initializing it. But when we use it subsequently, we can see we are actually no longer executing this whole function block again. Now we're just using the value that was returned from it. So this is our class scope. Now our next level up is going to be the module scope. So the module scope, and I'm going to take this, actually we can leave this now, I guess, if we want to, but let's just rerun this one more time. So going through our output now, we can see an important thing here is here we no longer have this output again like we've seen previously, and we are only using it once, in this case the first time we use it in test 1. If we were to move test 3 up, then test 3 would be the first time that we use it, and we'll actually no longer see the initialization in tests 1 and 2. So we can see here only for test 3 do we have this setup. So our module scope is essentially a file scope. Every single different file that we use this in, we will have this setup. So let's take this over and let's add here some like test4 like this. And now we're just going to execute all of our tests. So we can see here test4 is going to have it because it's in a different module, it's in a different file. But all of our tests in this file here, only the first time we have it, we can see it. And if we add another test here, test 5, then test 5 is not going to have it because test 4 is going to be the first one executed in this scope, and it's going to do that setup. So that here is our module scope. Next up, we have the package scope. The package is just going to apply for our whole package. So we can see, going through our outputs, we're only going to call this once, as we can see here, like this. But if we now create another, let's say, subpackage here, or a submodule here, subpackage, we're going to, let's give it a name here, some other testing dir, and I'm going to provide an initialization file here, init py. I'm going to add a test file, make sure to have test underscore as a prefix here, tests, test, call it test underscore more.py. Have here test 6, actually let's go over here, yeah, copy test 6. All right, so running our tests again. There we go, test 6. Okay, so test 6 again initializes it. So here we see we're no longer initializing it until the very first time we encounter it, but now that we're in a different scope, a different package scope, which we encounter here by going to a different directory, we are again, well, here it is, here, initializing it. And notice, again, with the conf test, we have access to all of the fixtures defined here, even in the subpackages. All right, that's our package scope. And finally, we have our session scope, which means this gets initialized only once across the whole testing session. So we can see here, also here, we don't have it. Only the very first time that we use it here is it actually initialized. All right, so these are the different scopes that are available to us in these PyTest fixtures. And yeah, you can see that, depending on how often you need to have this recreated, and also maybe how expensive those operations are, maybe you want to use different scopes, depending on, again, how you want those input parameters to be like, or also is it difficult, expensive setup operations, and even does there need to have any sort of like removal procedures? Because something that we can actually do is if, like, let's say we have a database connection here, so we set up a database connection, we fill it with data, and then we want to return the database connection that we can use. What we would do is we would actually use a yield keyword here instead, and then now afterwards we can have some sort of teardown stuff happening. So what that means is once this fixture is done using, once we've used it the very last time in our scope here, then we're going to execute the rest of the stuff. So we can see here at the very last stage, we now have some teardown stuff going on. And at the very first stage, we have the initialization stuff going on. If we change our scope here all the way down to function, we're going to see this at every single step. And you can probably imagine that as we're changing our scope, that stuff will change accordingly. So whenever we finish using this in our scope, then we will execute the stuff after here, which can be really nice to do things like, for example, cleaning up the database or closing the connection to the database or, like other stuff like that. So yeah, so that's going to be our scopes here. Now, one other thing that we can also do is we can have this auto use parameter. And if we set auto use to true, then every single test is actually going to automatically use this fixture. So going into test 3, for example, where is it? Further up. So here we can still see we're initializing the fixture. And if we remove it from here, because we still have the function scope, I'm pretty sure. Scrolling up, so yeah, here, test 3, and here we can see, okay, so we're still using it. So there is this option to auto use, which, as you notice, I have to take this out because otherwise we're going to fail in that regard. So if we look at test 2 inside of our class, class test 2 here, we can see that the fixture is not named because we're not providing it as input. But in some cases where instead of needing it as like input values, but rather you want to do some sort of just, like setup initialization and teardown stuff, just some behavior that doesn't need to return anything, then you can also have an auto use flag here, which essentially will do this creating and tearing down behavior if that is required for your tests. All right. So we've gone into a lot of different variations in our fixtures here, and I hope now you more clearly understand how these, or what these fixtures are actually used for. One more thing I'm going to do, going back to our original example now, is I'm going to have our user service here, and I'm going to provide this as input instead, like this. I'm going to cut this out of here, I'm going to put it into our conf test, and I'm going to define here our user service like this, and it's going to be a PyTest fixture, and it's going to take the profile infos and the user's content fixtures as input. So it's going to take these two fixtures here as input, and then we don't need to call a user service. This name here that we return, which we also saw from the val here, does not need to match this name. The name that is important here is the name of this function. This could be v, this could be whatever. But I'll just leave it like this. All right. And we also need to import our user services, so we're going to say from app.services.user, we're going to import our user services. And now we can also remove this import here. And let's just comment out all of these failing tests so that our output is not spammed. Run this, there we go, one test passed, and look at how nice our test looks now. We have essentially the user that we want to delete here defined within our test. We're performing the action, and we are asserting that the action was completed in the way that was expected. And everything else, all of the fixtures that we need to use, we will create elsewhere with a proper scope and then just provide them as input parameters. So yeah, this is really nice. I guess the one other change that we could do here, rather than providing these as input like this, now that we have them as attributes, they're actually directly accessible as attributes within our class like this. And then there we go. So yeah, this is also an option for us. And on that note, something that we could technically also do if we wanted to, if these variables don't need to be reused outside of the scope, we can actually put an underscore prefix in front of them just to have them be essentially like hidden or private, in this case, I guess functions or fixtures, because they don't need to be reused outside of this function. So if we do have to reuse them, then we'll take this underscore away. But if we don't need to reuse them outside of this function, what did I click on? Then we can even put an underscore. Oh yeah, now we need to put the underscores here, of course. And the underscores here, like this. So just as a small side note for some formatting stuff, if these things don't need to be reused outside of the function they're defined in, we can put an underscore inside of them to make them private / hidden. And then the stuff that we do need to reuse will have the proper names. So yeah, this is how we can go about creating a proper structure for our tests that have reusable input and output parameters as well as reusable variables that we can use across all of our tests to make sure that everything is properly structured, our input and output is defined properly. All right, so we've set up our unit tests, or right now just a singular unit test, but kind of started looking at this. And obviously the way that we would go from here is writing unit tests for every single one of these functions that we have here. And then we can actually also write unit tests for the functions here themselves. However, there's also some more stuff that we can do, which is called integration tests, where we actually test our application and kind of mock as if it were running. So what we're going to do is, rather than calling the functions, we're actually going to start up a testing client for our application, and then we're going to send some data to that endpoint. And although we can't test the internal workings necessarily or have access to the internal stuff, those are all things that will be tested in the unit tests. And then in the integration tests, we can make sure that the response codes as well as the response values are correct. So that's what we're going to do now. Now the first thing that we're going to do here is I'm going to create a unit tests directory, and I'm going to put all of our unit test related things in there. So now we can do, for example, pytest tests like this, and everything should still be running. And I already created an initialization file for us. Perfect. All right, so that still works. Now I'm also going to create here integration tests. And here again, we're going to create our initialization file. I'm also going to have a conf test.py where we're going to have our fixtures defined. And I'm going to say test user endpoints.py. Okay. All right. So the first thing that we're going to do here is actually, let's just write like a boilerplate kind of thing here that we can fill in a second. So let's see, what endpoint do we want to test? We'll go in here. Let's hopefully choose something simple. Let's do the delete. Just testing delete. Test delete user success. We're not going to do anything here. And then we're also going to do here test delete user fails. For example, when we try to delete a user that doesn't exist, that should fail. All right, so we need our conf test file. So we need our fixtures. Now what we need in this case is we need some sort of client or application that can emulate the running of our actual application, because we don't want to like spin up our application and then test against it, but rather we want to do this all just defined here as tests. And now to do this, we're going to say from fastapi.test client, we're going to import test client. And then we're going to create we're going to import PyTest. We're going to say pytest.fixture. And actually, we can already set the scope now. We'll set the scope to be session scope. So we're going to create this once. And here we're going to create our testing app. And now what we need to use is this create application. So we're going to say, here we are. No, here. So now we have to import this. So we can do from main dot, from main import create application. There we go. And now we're going to create our app like this, which is going to call this create application, which is going to run all of the stuff for us. Now we have our app returned here. And then we're going to say our testing app is equal to our test client. And in here, we're going to pass our application like this. And oops, there's a typo here. And then we're going to just return our testing app like this. All right, so this now gives us an application that we can use that's set up for testing. And we'll see how can we use that, well, right now. All right, so to start off with, we want to test that the user delete works. So I'm going to create here conftest.py. Just on the very outside, I'm going to import pytest. Oops. I'm going to create here another fixture called valid user delete ID. It's going to return an integer for us, and it's just going to return the ID 0. This is going to be our pytest fixture, and we could set the scope here to session, but in this case it doesn't really matter because there's really no cost to this. But if we want to, we can also set the scope here to session, because this is not something that needs to really be repeated. All right, so the reason that I'm putting it at this higher level is because we actually also have something similar here, the user to delete. So what I could do instead now is just replace it like this. And now we know we're using a valid user to delete ID that should succeed. And we can also reuse this in our integration. So here we want to have our test client. So we're going to say here our testing app as well as the valid user to delete. So going to our routes, we want to delete our user. So we're going to post to this endpoint with a delete method. So we're going to say testing app dot delete, and we want to, oh dear, there we go. We want to put the valid user ID and the data that we want to send. Just looking at our routes, doesn't look like we're sending any data, so we don't need to provide anything extra here. All right, so now we want to capture the response from this, and we want to assert, and now we're in our response, we have access to, for example, the status code. So we can say we want to make sure that the status code, for example, is a 200 code to make sure that our user was deleted successfully. And that's really all that we should be testing at this point. So let's first run our unit tests just to make sure those are working because we've changed something there. And now let's go ahead and run our integration tests, make sure those are working. And oh, we're missing an extra module that we need to install. So I'm going to deactivate our environment here. I'm going to do pipenv install. For now, we're just going to use this as a dev dependency. We're going to install the requests module like this. So waiting for this to install. This is a really nice library that we'll look at in a little bit. We haven't really used now, but it's something that you can use with Python to send HTTP requests. And obviously this will be really nice if you have to use other APIs, then you can use the requests module in your code too. But right now, since we're not using it, we're only including it as a dev dependency. But we'll look at that library in a little bit later. So we're going to reactivate our virtual environment. And let's go ahead and run that again. Tests, integration tests. All right, so something here failed. Okay, looks like we have the same problem. Test user endpoints. Oh, no, we do actually. This is the one that succeeds. So let's quickly take a look at this. We have a 404. So let's quickly take a look at our routes here again. And okay, so we have this extra prefix that I forgot to include in our tests, which is likely the cause of our issues. So I need to make sure that we actually have the proper prefix here, so it's going to be user. So let's try that one more time. There we go. All right, so now we are green. And again, I just forgot to put this prefix here, which we've defined at the very top of our router, which will be added to every single one of the routes that we have here. So what did we just do? Well, we created an application that we can use for testing. And in this case, we're sending a delete request to our application, and we're expecting a 200 status code. Now, the interesting thing is because we're using the application here, this is actually now going to fail because now the user has been deleted. So this should no longer actually work. And we'll actually see that we get a 404 raised, which should happen because once our user can no longer be found, here it is, we're going to be raising a user not found error, and then we have our exception handler. Here for user not found, we're going to return a 404. All right, so going back to our tests. So in this case, we should have a 404. And actually, also to show you something else that we can do, if we print out our response.json, this will actually give us the JSON response that we're going to get from our application. So printing this out, we can see here, this is it. The response that we get, the user does not exist, which is exactly what we expect here. So if we wanted to, we could also specifically test for this if we would like to. Something like our status code, if calling it a second time, it's going to be 404, and that our response.json is equal to user does not exist. Like this. Maybe we call this second response so that we can differentiate them like this. Okay, so running our tests again. So now everything is passing again. Great. So yeah, we were able to test our endpoint like this. And again, this is data going in and data going out, which is what we're testing currently. Testing that our user delete fails. Well, essentially we kind of already did this here. So what I'm going to do is I'm going to actually take this and do it like this. Because first we just want to test that the endpoint even works. And if we test it that the endpoint works, then maybe I can test that calling it a second time. Maybe we'll say your test double delete user fails, because that's really what we're doing. That's what we're testing here. And so in this case, we've encountered an interesting thing, which is our application here is on session scope, So what we want really in this case is we want a function scope, because if we're rerunning it here, we assume our user is back in. So if we run it on a function scope now, again, everything's going to be working, but if you run it on the session scope, we've already removed the user here. So in this case, just to have kind of consistent input and output, I'm actually going to run it on a function scope. We can run another test, test invalid user ID fails, test, and then delete invalid user ID fails. And I'm just going to copy this over for now, as well as take this over. And this is going to become invalid user delete ID, which I'm also going to define up here. Invalid number 1. All right, so now we also have an ID that should not exist and that should fail if our application had nothing added to it. And so if we run this, then this, should also succeed, as we can see here. All right, so now we have different tests for the same endpoint based on, different input conditions. Because in some cases, in this case, the user we know should exist, so this should always succeed if we run it the first time. If we run it twice, we expect the second time round to get a 404 response. And if we run it on an invalid input, we should also expect a 404 response. So there are different avenues that we can approach here, and something that could happen is if you didn't implement everything and you just had this, then you would say, oh, okay, it works. But then actually, a user tries to delete it twice and they get an error, and then you will add a case like this, and then they'll find that they tried to delete a user that doesn't exist, and maybe this will already cover it, but if not, then you would add another test like this to make sure, like all of these edge cases that you are uncovering as the application is running, all of those bugs are accounted for. But ideally, obviously, you try to think of as many edge cases as you can while you're developing, so that you are the one that is building the solid application, but it's not the users who are running into problems and you're kind of updating it and fixing it. But either way, now that we've added these unit tests, we know that if we ever change anything, for example, if I change this here to now be a 400 response, my tests are going to fail. And so now I already know the change that I made is causing issues. The application is no longer working as expected, which is really nice, because if I would have released this and then I only found this out later, obviously that would have sucked. So now I already know the change I made here is incompatible and is going to cause other issues elsewhere. So we can see here we were able to use this delete method on our testing application, because that is the delete endpoint that we have here. Some other stuff that we could try. Let's try sending a put request here. So creating a new user. And for this, we need the full user profile. So I'm going to create this in our overall conf test in case we want to reuse it in different places. And I'm going to say from app dot, schemas. Oh, geez, what is going on here? App.schemas.user, we want to import the full user profile. And then I'm going to create a pytest.fixture here with a session scope, sample full user profile. It's going to return a full user profile, and just return it. And let's see what we need for initialization. We need a short description, a long bio, as well as the contents from user. So I'm just going to keep these here as placeholders. And the user stuff, we need the username and the liked posts. Liked posts. And like this, AVC, DF, short description. Something like this. So this should suffice. I'm going to hit Command-Alt-L to do kind of auto formatting for me, just to make it a bit prettier. Okay, so now we have our sample full user profile. So now we're going to say def test put user returns correct results. We're going to use our testing app as well as our sample full user profile. and we're going to get our response. Actually, I noticed up here this should not be second response, but this should be just response. Just, because in this case it's not the second response, it's just the response. This came from the copy pasting. So we're going to say our response is our testing app dot put. Our endpoint is going to be /user / and then our user ID. For now, I'm just going to define the user ID here. User ID. Let's do it for user 1. And now to send data, we're going to have this JSON field here. And to send the data that we want, we can't just put our model here like this, but we actually have to convert it to a dictionary to send. And we can do that by just using the .dict keyword on it, which will convert it into a Python dictionary that we can then now send. So we have our response here, and now we want to have just assert that our response status code is 200. And I don't think we get any information back. Nope. So that should take care of that. And new line here, just for proper formatting. Let's run this. All right, something went wrong. One validation error for full user profile. So it looks like light posts. Looks like I created the thing wrong. Oh yeah, there's a typo in here. Let's try that again. All right, there we go. Okay, so this works. We can add a second test. Test put user twice, returns correct result, and essentially we just do the same thing and just make sure that it's still valid, because it should work twice. And let's see. Oh, all right, now we have our rate limiting thing. Okay, let's just quickly change that. Dependencies here, and let's change our limit to 50. Obviously, this is stuff that we should also be setting in our testing, but that's kind of sidetracking it. But this is also stuff that we should be able to initialize and stuff that we should be able to set for our testing here. So maybe this is one of the dependencies for the rate limit that we actually want to inject here wherever we set this up. Yeah, just so that, when we're testing, we don't run into that problem. Okay, but right now I'm just going to quick fix it like that. Okay, there we go. Okay, so everything is working as expected, and then let's just do one more different test just to show you the different things we can have. So now let's test that our get is working, because I want to show you that we already looked before how we can access the output here with the .json, but let's just do it in a proper example. So we're going to say test get valid user works correctly, or user returns correct result. We have our testing app, and we're going to use our valid user delete ID, which maybe we want to rename actually to valid user ID. So I'm going to just use the refactoring here that's part of PyCharm, and I'm just going to remove the delete, and it will actually update it everywhere for me where this is used if I click on refactor. And I can click here, do refactor, and it will apply all the changes for me. So let's see if that worked properly. Yeah, there we go. So we can see valid user delete. It's complaining about, oh yeah, here we go, because I didn't define this yet. So just as a quick kind of side note, very easy way to make changes like that without having to go and find all that stuff. All right, so we have our valid user ID. We're going to set up a response. We're going to use our testing app. We're going to send a GET request this time to our /user / valid user ID. And now we're going to assert that our response.status code is equal to 200. And we also know, and this would either be based on how we set up our database, for example, based on our seed users, or in this case, it's just how we set up our application. We know the values that we should expect here. So we can say, if we look at how we set this up, we know that our liked posts should be this, for example, or we can check that our long bio is this. So I'm going to check for the long bio, for example. So I'm going to assert response, .json, and here I'm going to access the long bio attribute. This should be equal to this. And again, with this, we can access the JSON response from our response value, which is the same thing when we were using our fast API in the documentation. When we hit send, it's that output value that we've seen. So to access it here, we just use this .json, which will let us access that return value. And I'll also print it out. And maybe I'll just assert false here so that we can see that real quick. Assert false, yeah, so this is where it fails. Good, that means the other stuff passed. So yeah, here we can see that this is what we have returned, and this is, this is exactly what we expect, right? Because this is exactly the schema that we have defined here. But again, just showing that with the .json, this is how we can access these return values, and then we can treat it essentially like a Python dictionary and access the data like that. So if I remove this assert false, remove this print statement, just to keep it clean now, then this test is also going to be succeeding. So now we've seen how we can set up integration tests, which actually helps us test the input and output of our endpoints without testing the functions inside, but rather what goes in and out, as well as how we can send data, receive data, look at status codes. If we wanted to, we could also do something like, I'll just show you the response, the printing statement here, but we could also do stuff with the header if we wanted to. This way, for example, we could also test the rate limits, assert false. So yeah. So this is the header that we have, for example. So one way that we could test the rate limit, for example, is let's have our testing application here, here. So our scope is a function scope, actually, so that's already okay. But yeah, something that we could do here is essentially then just send a bunch of requests and just make sure at some point we raise an error. So one way that we could do that, for example, if we wanted to just real quick, def test rate limit works. We're going to have our testing app, and let's put in here a PyTest fixture. We'll just keep function scope and testing rate limit, which is just going to return the rate limit value that we're going to use in our testing. So right now it's going to return 50. And then what I'm going to do here is have a quick for loop. We'll say for I in range testing rate limit, and then we're just going to do testing app dot get, and then we'll say f / user / and then maybe valid user ID, and we'll also include this one here. And so now if we want to check that we actually get an error from here, so if we run this 50 times, this should fail upon us. No? Oh, probably want to run it more than 50 times, as 50 is our limit. Times 2. No, it's still working okay. Let's look at our rate limits here real quick. Where did I change that? So our limit is 50. Let's print out our headers here just to make sure that that is actually working properly. Oh, yeah. Just to get that printing out. So let's take a look at our output here. Right. So yeah, so we have it included, right? Of course, we're raising our 429 status code here, and so that's what we should be checking for. So what we could do, for example, is say if maybe this parameter is not in our response.headers, then we want to assert that our response status code maybe is 429, something like this. And let's run this. And now it's complaining about something. Oh, there should not be an is here. Okay, there we go. So yeah, quick debugging here. One thing I noticed, this should be uppercase X. Oh, so this is uppercase X, so it looks like it just got returned lowercase to us, but yeah, so we should be defining that as uppercase. Okay, so yeah, this is how we can go about our integration tests. And, pretty useful stuff. Obviously, there's a lot more things that we can test if we want to, a lot more different edge cases. But the point is, like, if we've tested an edge case, we don't need to test the same edge case multiple times. But, this gives us a lot of security in terms of running our application, just because, when things go wrong, like if I change this to like a 400 response, I just run all of our tests, one of them should fail. And that way we know if I make changes and I run our tests and they pass, I haven't broken something that used to work. So we can see here this failed because now we get a 400 response instead of a 429 response that we expected. This may not be the best way to test our rate limit, but I'm just going to leave it like this for now, just because our whole rate limiting thing here, it's probably a much better way to do this is all of this stuff should be configurable in a config class that we can pass in using environment variables, and then we can properly define all of this when we run it. And so we can define all of this stuff and not have it hard-coded, because as we can see, hard-coded makes our life very, very difficult. So that's why we always want to have this dependency injection, being able to pass all of these things down, basically down the line, being able to define them when our things start up. All that stuff is good for us because it makes it really easy to change things around, to do testing, to deploy with different configurations. All of that stuff just becomes extremely easy, and when it's hard-coded, it's not easy. But yeah, we'll leave that for another day. All right, so continuing on with our tests, we've now seen some unit tests as well as integration tests. And we saw that in the integration tests, sometimes we were going and we were also making sure that things were failing as expected. And for our unit tests, well, currently we only have one, but I want to show you how you can do that too, and specifically also because here, for example, we're going to be raising specific exceptions. And so something that we may want to do is we want to make sure that we delete a user we know should not be there and that the proper exception is raised for that. So yeah, let's go ahead and do that now. We're going to go into our unit tests here, and we're going to create a new unit test that's going to be test delete invalid user raises proper exception. And we're going to take in our user service as well as the invalid user delete ID. We're going to mark this as an asynchronous test. And then we're going to do, so we want to have user service.delete user invalid user ID. If we run this as it is now, so pytest tests, and if we just run our unit tests, this is going to, it's going to succeed. Why is it going to succeed? Let's take a look at our invalid user ID, delete user. Let's print that out here real quick and see what's going on. Oh, of course, we didn't await our coroutine. Okay, so let's try that again. Oh yeah, we already saw that in the warning and the thing here too. Okay, so we didn't. So now doing it properly. We're running, and we can see, okay, we have a user not found exception. So we know this exception is being raised, and we expect this to be raised, but how can we write our test to make sure that this is being raised? So what we can do is we can do with pytest.raises, and then in here we can put in the exception that we want to have raised. So for example, we can just put in a general exception for now. We'll change that in a second though, but now we just want to make sure that it specifically just raises any type of exception. Now if we run this, we're going to succeed because Now what we're testing for is making sure that this piece of code here actually raises the exception. Now an important thing to note, you're probably already aware of this since we've been doing this for a while, but with the indents, if we're out of this indent here, then it's no longer going to work because this with statement has to be indented just like we have for functions and methods and defining classes, all of that stuff. So we want to make sure that anything that should raise an exception is properly put in here. Now obviously we want to be more specific than just this, right? We want to raise a very specific exception. So we can be even more specific. We're going to say from app.exceptions we want to import the user not found. And now we want to make sure that our test here raises this specific user not found exception. And if we run this, we can see now this passes. Now this is good because if this is, ever changed and maybe we just raise here like a general exception, then this test is going to fail. And it's important that this test fails because in our exception handler, we're specifically catching this exception. And now, if we don't have that anymore, then all of our responses where these exceptions would instead be raised are just going to be general internal errors or something like that. But instead we want to return 404s because that's specifically what this is for. So again, it's very important because we kind of protect the functionality of our application like that. So yeah, this is how we're able to test to make sure that specific exceptions are raised when we do specific operations. And now again, it's important to know that if we put in here and assert false afterwards, this is no longer going to execute because we have this exception being raised here. If we had an assert false here, it will fail because this assertion fails. But because we have it behind, we're raising the exception, and so this will actually no longer be executed. But if we unindented, and once again it will be executed. So just be aware of that as you're kind of structuring this. Now it's also important for us to be as specific as we can here, because for example, let's say here we have a key error exception. In this case, our test is again not going to pass because we're raising a user not found exception, but instead we're only looking for a key error exception. So again, the more specific we are about all of this, the more robust we make our tests and the more robustly tested we make our application, which means that as we introduce new features and changes and stuff like that, we want to make sure that the application is still working as intended. And the more tests that we write, the more edge cases that we think of, the better this can be because then we're covering more parts of the application and where it can go wrong. Now, obviously, you want to try to write as many edge cases as possible in the beginning, but also like tests will also come with time because it's likely that some sort of bug will go through no matter how hard you try. It's very likely that, well, not very likely, but it's probably likely that as things become very complex, you just forget certain things or you didn't consider something. And that happens, and the most important thing is just you make sure that you add all of those things to your tests to just make your application more and more robust. And obviously you can help catch those things by writing different edge cases and maybe testing out different inputs and trying to think of how are the consumers and the users of your application actually going to use it so that you can make things accordingly and you can prevent these errors and you can catch these errors in your unit tests and then fix them before they ever go out and a user has to encounter them. All right, so still staying on the topic of tests though, but taking a little bit of a detour so that we can come right back to it, we're going to take a quick look at how we can send requests with Python. So previously what we've done with our whole application here is build an application that accepts requests. So again, let's just kind of go over what exactly that means. Let's go ahead and launch our application here and open it up, refresh our documentation page. So right now we have our API server running on this address here. So this is going to be our local machine. And then this is the port, and here we're on the /docs page, which gives us this documentation rendered for us. So, for example, I can send a request to our server like this. and this will send data there, and our whole server will receive this data because we're using a specific endpoint, and then it will process it and it will give us back a result. So everything that we're doing here is building the functionality around having this thing here which can accept data to come in. But obviously, for example, the consumer of this API that we have built here will need to send this request. And it's very likely that even if you're building APIs to have certain functionalities, that sometimes you also need to send requests to maybe another API. So maybe you have some sort of API which, brings all the information about users together, but you need to go to another API which tells you, for example, the current user status, like if they're online or offline or something like that, so that you can have this live mark there too, and then just bring that all together in the information. Or, some other service which like looks up an ID or, whatever it may be. It's likely that at some point you will also find yourself needing to go to other APIs to request some sort of information. So yeah, that's what we're going to look at now, is how we can send these requests in Python. Now, looking back at our endpoint here, we can see this is the kind of output that has been given for us. So this is actually what has been sent using the terminal. And now over the terminal, we can use the curl command to send a request. So this would be the same as essentially kind of, if I copy this and paste this in here, just visiting this site. And so we can see here, this is exactly what we get, right? And here, this -h also indicates that we're sending some header data. And if we're actually adding something like we would here, if I just, send this, then we can see here there's some another -h. So we have two like header parameters that we're sending, as well as the -d. So this is the data that we're sending, which is the one that we were more easily able to like put in here. So yeah, all of this stuff is essentially things that we want to be able to do too. We want to be able to send different kinds of requests to different sites, essentially, being able to send headers, being able to send data. And that way, we can also use other APIs and get that information and be able to use it either in our code, well, always in our code, but either in our own APIs or in different sorts of programs that we're writing. Okay, so how do we do that? So now I'm going to take a quick detour from our application here. I'm going to close our application and our tests, and I'm going to create a new directory here called sample requests, where we're going to look at how we can send these requests. And I'm going to create one file that's going to be synchronous requests, because we're also going to be looking at asynchronous requests too, since we've also have some like asynchronous roots here, so we're going to be looking at that too. But let's start with the synchronous stuff. Now for this, actually what we really need is, if we go to our pip file, we've already installed this requests library, which lets us do these requests. So what I'm just going to do, I'm going to take this out, and I'm going to move this from here into our packages. And now I'm going to deactivate. And if we look at our pip file here, and just scroll around, I think we need to scroll down a little bit. Let's see here. So we have our requests library here. So we still want to keep this, but essentially, right, like we want to have this not as a dev dependency, but rather as just something normal that's going to be running with our application, assuming we want to send HTTP requests within our application too. So what I'm going to do is I'm just going to regenerate this lock file here using pipenv lock, just to make sure that after our changes, everything is still up to date and consistent. And yeah, it's going to build that for me and update it if required. And then I'm going to do pipenv install, and again //dev, so that I also install dev dependencies. And so we already have everything installed. Great. And now I'm going to go back into pipenv shell. So I'm going to go back into our virtual environment here. All right. So let's start at sending requests. I'm going to import requests here, which is this library that will allow us to send requests. And essentially, as we have these different endpoints, we have the get, put, delete, and post, we can access all of these in very similar methods, actually very similar to what we saw in our integration tests, where we sent a delete request, for example, to our testing application. So the syntax here is very similar. Let's have a sample get request. So the way that we can do that is we can do requests.get, and then here we can already see how we're going to be sending this information. So our URL, for example, that we want to send it to. And at this point, essentially what I want to do is I want to have our endpoint running, and then in a second terminal, I just want to send a request against our running application. So for example, I want to send a request to this address here. So I'm going to put this in here. And if I want to send any headers, I can put these in headers like this. I'm just going to keep mine empty for now though. And if we want to send some data, there are two ways that we can send this. One of them is using this data keyword, and the other one is using this JSON keyword. And we're going to look at just exactly what the difference is between these two, just so that you're also aware of how to use this. But here, for example, let's just put in, well, we don't need to actually send any data since this is a GET request. So we're going to leave this data field empty here, again, because it's a GET. Now, when we're sending this request, we also get a response. And so we want to make sure that we keep that response in a variable. So we send this request, a GET request, and then we get a response from the server, hopefully, but we will either way get a response that we will have in here. And so we want to store that response to be able to use it later. And right now I'm just going to print out our response like this. Now I'm going to open a new terminal here. And now I'm just going to launch our application here again, like this. So now our application is running. I'm going to go to my second terminal and see, just waiting for this. There we go. And now I'm going to just run this sample requests.syncRequests.py program. So I'm just going to run this program, hit enter, and we can see here the response that was printed out was a 200 response. And if we actually look in our other terminal, we can see here a GET request to this endpoint /user/0 was sent, which is exactly what we're doing here. And if I change this up, for example, for I in range 5, just so that we do this 5 times, and I run this, then you will see here we're sending 5 requests, or it's receiving 5 requests, and from here we are sending 5 requests. All right, so yeah, let's look at how we can do some of this stuff, how we can use this response actually. So we have this response object here, and if we print it out, we can see we just tells us the status code, but we can actually look at the status code by going into this status code attribute. So this is going to give us the status code. If we want to look at the headers, for example, we can go into response.headers. And if we want to look at the return data, we can go into response.json using this JSON method. These two are going to be attributes that we're looking at. This is going to be a method here that we're going to be calling. All right, rerunning this, we can see here our status code is 200. And now the important thing here is that this is actually an integer. So if we want to look at the type of this value, just so that we know how to use this, of each of these, oops, like this. So we can see here we have an integer, which is this 200 number. We have a specific type of dictionary that we can really just treat like a dictionary though. And here we just have a pure dictionary. So yeah, these are the different responses that are available to us. And if we want to look at, for example, the rate limit count, I'm gonna headers I'll say is going to be just going to store this in a variable so that we can reuse it. Rate limit info. We're going to go into our headers, and then we're going to look at this x app rate limit parameter, which should print out this string for us here. And yeah, for our response data, maybe I'll store that in a variable too so that we can reuse it like this. Response data. And here, let's look at the short description, which is going to be going into our response data and going into the short description like this. There we go. So here we can access, we can access all of these attributes essentially like we would with a Python dictionary. So yeah, this is how we can send GET requests. And then if we want, or if we need to, we can add specific header parameters here, but currently we don't need to do any of that. Let's look at sending a post request. So we're going to go, we'll say post response, and then we're going to use a request library again, .post. And now let's see what post endpoint we have here. It's going to be /user. So we're going to post to this address here. Headers. Again, I'm not going to really include anything. I don't think it's like necessarily essential for us to fill this out in this case, but again, if there are any headers required, if you're using a different API, for example, like some sort of API key that you need for authentication, then you can include that in your headers. For example, to keep it very simple, something like access key, and then you would put the value here. This would usually depend on the implementation, though, of maybe how it's handled directly there, and will also be available with the documentation. So now let's send some data. Here we're going to send a dictionary. So what are we going to send for posting to here? Let's try it out, and this is the sample data that we have. So let's have here sample data to send is going to be this. Our name is going to be, say, Bob. Like post is going to be 0, 1, and 2. Here we'll have some short description, and here we'll have some long bio. And then we're just going to send the sample data. And from our post request here, we're going to print out post request response. And let's just look at the JSON response that we get from here. Now, the important thing here for us is also at this point the difference between this data and the JSON attribute. So in this case, we have the option of sending both data or using this JSON parameter. If we want to send the data using this data parameter, then actually this needs to be encoded into a string. And so what we need to do for this is we're going to import the standard JSON library that will come with Python. And what we're going to do is we're going to say JSON data, and we're going to go into our JSON library here. We're going to call dumps, which is going to dump this into a string. And we're going to put in here the data that we want to convert into a string. So let's just look at this too. We're going to print out JSON data. It's going to be this. We'll say original data is going to be this one here. So not changing this yet, which will fail in a second. Let's go ahead and run this again. So here we have our JSON data, which is this one here, and our original data, which is this one here. Now, something that you don't see, but I'll add this here explicitly, is the type of each of these. Oops. Rerunning this. So our JSON data here is a string. So essentially what we've done, or what this library has done for us, it's taken our dictionary it's converted it into valid JSON format and has now stored it as a string, which we can see here. And this is stored as a string, whereas our original data is just a Python dictionary. And so now if we want to send this data, we can send this encoded JSON, or this transformed into JSON, by putting this here, like this. I'm going to comment this out here. And sending this, now we can see that the response that we get is that the user with ID 1 was created for us. Alternatively, let me just comment this out here. We can also use the JSON parameter and instead here put in our raw data in the dictionary format. So alternatively, we can use this one, which will give us the same result as we can see here. So these are two different parameters that we can choose depending on the input method that we want to have. But we can see in either case, it's giving us this user. Now you may be wondering, okay, we're sending it to the post, which should be creating a new one. Why is it always creating user ID 1? That's because we use this reload to launch our application, and we can see here that every time we change our file here, it's just reloading the application. We can see here it's now sending a GET request as well as a POST request here. And these are actually the responses that we're getting here too. So we can look at post status response, which is going to be our post status code. And we can also look at the headers, post response headers, like this, which we have here. So we can see we have the response, which is a 201 for created. And we also have the headers here available for us, which also includes the rate limit parameters. And we also have here the request response, which gives us the ID of the user that was created, which we can use from here. So for example, if we wanted to add this, if we had to use our application and another application, we could send this request to our application with the data that we need to create, and then we would get this user ID back. And then we can continue working with it by just looking at the JSON response of our request here. And now we can do similar things for the put and the delete. We're not going to go through them because the examples are going to be the same, but we also have this .put, which is essentially going to work just like the post, except that we have the put. And then we also have the delete, which again is going to work just like the others. Yeah, so this is how we can go about sending requests synchronously in Python. And essentially what that means for us is that when we're sending this request, our program is going to be waiting until it gets a response. Now this is not super ideal. So in the next lesson, we're also going to look at how we can send asynchronous requests. And again, the reason that we're doing this is because it's currently our application obviously only accepts requests and does stuff with them. But it's likely that at some point you are also going to need to access other parts of the internet, be it some other API that was developed by some other person in the company that you're working in, or some sort of third-party API that you want to use. For example, maybe like a Twitter API where your application will accept certain data and then it will create tweets or something like that and send those tweets off on Twitter. So essentially at some point you want to access the internet outside, and the request library is going to allow us to do that. But yeah, we're also going to look at the asynchronous example, which is going to help us speed things up a little bit too. But yeah, we'll do that in the next lesson. All right, so now that we've looked at synchronous requests, which happen one after the other, we're also going to look at asynchronous requests. And for this, I'm going to deactivate my virtual environment. I'm going to do pipenv install aio http. This is going to be a library that we can use that will allow us to send asynchronous requests. And we'll go ahead and install that. Now, the very big difference here between synchronous and asynchronous, without going too deep into all the details, because again, there's a whole nother course covering all of this concurrency and stuff that's several hours long. So we'll be taking a pretty big, walk in the sideways direction, or a pretty big tangent. But the big difference here is that if we're sending synchronous requests, they're essentially happening one after the other. So we send a request, and then our program pauses until we get a response back. Whereas with asynchronous, we send a request and then we give control back to the program, and it will continue running other things until we get a response back, at which point it will continue with the part of the code that was waiting to get a response back. So that's a very, very big difference, is that with asynchronous, and this is also why we, again, talked previously about this asynchronous here, is essentially whenever there's any waiting for network communication to happen, we can give control back to our program, and it can do other things while we're waiting for a response here. And when we get the response, we can then continue with execution in this part of our program, because there's no reason for our program to sit around idly doing nothing while it's just waiting for data to be sent back and forth over the network. That's a waste of our computing time. So it's much better to use this asynchronous stuff, which rather than the synchronous, which just waits and the program is essentially frozen or paused until it gets a request back and then continues. With the asynchronous, instead, we are, sending it, and then we can wait and do other stuff, and then when we get it back, we can continue. All right, so let's create a new file here, which is going to be our async requests.py. And what we're going to do is we're going to import AIO HTTP for this. And, I need to activate our virtual environment again here. We're going to import AIO HTTP for this. And we're also going to import async IO, which is the standard asynchronous library that comes with Python. I'm actually going to put this first, because first we'll do our kind of native libraries, then we'll do our third-party libraries. All right. So yeah, we'll see why we need this in a second, is because unlike FastAPI, where we actually use Unicorn, which kind of starts this whole asynchronous process for us, in this case, because we're going to be running a sample example, we instead need to kickstart this process ourselves. So this is what we're going to be using this library for. But again, don't worry too much about it. Just rather, the points that we're looking at here is how we can send these requests using Python, so that in the next lessons we can look at how we can create tests for these sorts of things, because it's very likely that you'll be doing these things, and also definitely you want to be able to set up tests for them. But in your tests, you won't be able to send data to outside services. It all should stay internal to your tests and not be dependent on other things running or not running. All right. So we're going to start off with just defining an async function. And here we're going to call this sample request. And what we're going to do is use a new keyword, or we're going to use our async keyword, but we're going to do async with, which is going to asynchronously start this context for us. And every single time we use this async or await keyword, every single one of those is an opportunity for us to give back control to the program. So we're going to be starting a HTTP client session, and we're going to be using this as a session. So very similar to how we open files with this sort of way. Instead of opening a file now, we are instead starting an HTTP session, and we're going to be storing the session in here so that we can use it later on. This is a little bit more explicit than we had in the synchronous request example, where you'll see in a second, or all we did up here was request.get. For our asynchronous, we have to do a little bit more work. Not that much, but just a tiny bit more. Now we're going to send our get request. So it's going to be async with, and then we're going to use session.get. And now our syntax is going to be very similar. We're just going to send here our URL. And then we're going to save the response as response. So now we've started our session, and during this time when the session is being created, we have the opportunity to give back control to the program. We're sending our request, and while this request is being sent, the data is going out, the data is coming back, we have the opportunity to give back control to the program. And now we can print out, for example, our response status code. Oops. Status. Notice the keyword here is a little bit different than what we've used in our synchronous. You can also print out the response headers. Now, an interesting point is if we want to look at the data that comes out of it, we can't just do response.json, but instead this here is actually a coroutine, so we actually have to await it, which again gives another opportunity to give back control to the program. So this is how we can, maybe we'll call this sample async get request. So yeah, so this is how we can send a request using asynchronous rather than synchronous. And the unfortunate thing is I can't just type in here await sample async request because this is not inside of an async function. So at this point you're probably like, well then how do I run this? Because if I create an async function, then it's not going to be called until I call it, and I can't call it without being inside an async function. So that's where async.io comes in, and we're just going to do async.io.run, and we're going to give it the entry point of what it should be running, which is just going to be our function here. So I'm going to go ahead and let's just run this and then look at this a little bit more detail again in a second. Post Python sample requests, and then the async one. Is our server still running? Yeah, still running. All right, so we can see this is our status that we have. This is our header that we have. And here is the content that we have as a response. So we can see it works just like the synchronous case, with the only big difference being that this is now asynchronous, which means when we include this with all of our other asynchronous stuff, we now have the opportunity to give back control to the program or to our application every single time we're waiting for data to be sent back and forth. So this can be a really nice thing if you're building an application that needs to send a lot of outside requests, that you instead use asynchronous, because with that you can still send data in and out using these requests that we have like get, post, put, delete, but you're not going to be blocking your whole program from running while it's waiting to receive data. Now let's also look at a sample post request. So I'm going to just take this, copy this, change this here to post. I'm going to send JSON data instead. And going back to our sample requests, it's essentially going to work in just the same way. So I'm going to take this, bring this over here. Oops. It's going to be the data that we want to send. And using the JSON keyword, I'm just going to put in our dictionary here. And now I'm just going to run this one instead. So we've changed this to post. We've updated our endpoint, since this is the post endpoint that we need. Remember, from here, this is our post endpoint. And this is the data that we're going to send, just using a Python dictionary, using the JSON keyword here. So let's go ahead and run this. And yeah, here we can see we have our user ID responded. The status code is 201 since it was created. And this is the header that we have available for us. So yeah, this is how we can go about sending post requests versus sending post requests but asynchronously versus sending these synchronous requests. Now again, the put and delete are going to work very, very similarly as to what we actually have here. Except obviously, of course, we're going to be using put and delete keywords instead, and for put we want to send the data, and for delete we're going to treat it very similar to just a get request. So yeah, this is how we can send requests in Python using both the synchronous method, which if we're using this it will block execution. Here it will block program flow, and essentially the program will pause until a response is gotten and it will return. Whereas if we use our asynchronous, if we're just including this in our application, then instead what it's going to do is every time that we use this async here or this await, it is instead going to give control back to the application, and if there's anything else that needs to be run, that will be run instead. And yeah, with that, you now have the ability to use other APIs created by other people, be that colleagues in your team, be that other APIs within the whole organization, be that third-party APIs either for your own projects or also for work projects. Again, like I mentioned, like a simple case would be the Twitter API, being able to use that, send data there, and essentially post tweets, maybe, or some other stuff using an application that you've created. All right, so previously we've taken a little bit of a detour looking at how we can send synchronous as well as asynchronous requests using Python, using the requests library here, as well as over here we had our AIO HTTP. And this is essentially kind of the other side of currently we've just been building our application so that people can send requests to it to get information. But obviously sometimes we want to be able to send those requests to either third-party APIs or to different internal applications maybe that our company has developed or that other teams in our company have developed. All right, so now that we've learned about how we can send these requests, let's go ahead and do some tests for them. And what I'm going to do here is I'm just going to change this up here a little bit. I'm going to remove all of this testing stuff, or rather this printing stuff that we used to test. And what I'm going to do is, let's take all of this away, and let's just create a very simple function. And that's going to be get user, and it's going to take some sort of like user ID. It's going to be an integer, and maybe we'll have get and parse user. And so the main thing here that it's going to do is it's going to, oh, why is my indenting so weird right now? Let me fix this here real quick, see what's going on with our indents. Okay. All right. That's weird, but I'm not sure what's going on with the indents right now. We'll see what happens. Actually, this is really annoying. Get and parse user. Just delete all of this. Still weird. All right, whatever. I guess we're gonna leave it weirdly visually indented right now. I'll probably just otherwise just create a new file or something to get rid of this. It doesn't look normal, but okay, whatever. Not that important. Okay, so we're gonna have our user ID here, and what we're gonna do is we're gonna send some request, and we're going to send that to, let's say we have some sort of like URL here, and I usually want to like split this out. So we'll have some sort of base URL that would look like this. And then we have maybe the actual endpoint like this. And then we have our full URL would be the base URL plus the endpoint. So first of all, when I like try to send requests, I would generally split it out like this because it makes it a little bit easier to form URLs. But even here, like I would not include this information in this function, so this would usually be like defined elsewhere, maybe in like a configuration file or so. But for now, what I'm going to do is I'm going to put all of these as input parameters. So we're going to have a base URL that's going to be some sort of string, and then we'll have our endpoint prefix, which is also going to be a string, and then we're going to have our user ID. So our base URL is just going to be like whatever here. Our endpoint prefix is going to be this component. So our full URL is going to be our base URL plus our endpoint prefix plus the string user ID. Okay, so this is what's going to form our actual URL. We're going to pass our URL here, and here. Take this away, and yeah, endpoint prefix. All right. Yeah, okay. So now that we have our response, really what I want to do is let's just return the response.json. And obviously things that we could do is like some sort of like parsing here or whatever. But yeah, right now we're just going to return the JSON response, and that's it. And I'm going to delete the rest of this stuff. Okay. So, okay, it looks like reformatting. Command Alt L, which is the auto reformat, fix that indenting problem. So, all right, good. Now it looks much prettier. Okay. All right, so we have our kind of basic function here that uses some sort of endpoint. And now what we want to do is write a test that, tests this. But the thing is, when we're writing unit tests, we don't want to be dependent on external services. Um, so how can we write a test without actually sending a request somewhere? That's what we're going to look at now. So first I'm going to deactivate my virtual environment. I'm going to do pipenv install --dev responses. I'm going to go ahead and install that. So responses is a library that allows us to essentially mock and configure these in and outbound, or these outbound requests. So what it does is when it sees this request going out, rather than letting it go out, it's actually going to like capture it, and it's going to send back predefined data that we're going to predefine. And in that way, we can test our functions that depend on getting data from a URL by essentially putting into our tests, like let's just assume that this URL returns this data, and then we can test our function, because we don't want to test the other endpoint, right? Well, I mean, we could do that in some integration tests, maybe, although even there, we don't really want to go out to other endpoints. So generally, like we want to kind of keep that out of our tests, but we're just going to assume that their thing works as expected. And then when we get responses that we would get when things are working as expected, we want to make sure that our code works as expected. So we're just going to assume that their stuff works, and we're not going to be dependent on their things. Okay, and then obviously, when this would be more complex, we would actually have error handling in there too, because maybe their things don't always work, and so we want to make sure we have proper error handling for those things, and then we can also write tests for that. But let's just stick with the basics. So I'm going to create some new tests here, and that's going to be test sync requests.py. And what I'm going to do is I'm going to first say from sample requests.sync requests, and I'm probably going to also put an init file in here so that we also turn this into a package. All right, sample request.sync requests, I want to import get and parse URL, get and parse user, sorry. Okay, so this is the function that we want to test, which again sends an HTTP request. Okay, so writing our test, we're going to test get and parse user works properly. And now what we want to do is we want to have some sort of user ID. Let's set that to 0. We're also going to have some sort of base URL, and I'm just going to set this to empty for now, but this could obviously be, whatever. And we want to have some sort of endpoint prefix, which is what we need. So for example, /user/. And really, definitely we could all, if we're going to reuse these, we could also make these into PyTest fixtures, but because I'm only going to be using this for this one test, and this is kind of a detour from our application, and I'll delete this code later on, for now, I'm just going to keep it all within this test here. But obviously, if we're reusing this, we could also make these PyTest fixtures. And now what we want to do is we want to have our response here, which is this, and the information we need to send, see by hovering over. So we need the base URL first, so we're going to pass that. Then we need the endpoint prefix, and finally we also need the user ID. So we're going to get our response, and maybe what we want to do is we want to assert that our response, maybe that the type of our response is a dictionary, and maybe we want to assert something in there. So maybe we want to assert that response user is equal to user ID, because maybe that's what our parser does, is it like formats it into this. And so this is kind of like the output format that we would expect. Double equals here. Okay, so now we kind of need this part that responses will do for us, which is right now, if we were to do this, we would send a request to this URL, which is obviously nothing right now, with this prefix, endpoint prefix, and then with this specific endpoint parameter. But obviously we don't want to send external requests. So I'm also going to import responses here, on top of my test here, I'm going to use the decorator responses.activate, and then I'm going to do responses.add, and now we need to see what kind of request we're sending. So command clicking on here will just take me to the function very quickly. So we're sending a GET request. So I'm going to go into our responses here. I'm going to do responses.get. So this is the type of request that we're sending. Now I'm going to provide the URL here that we're going to, and I'm going to use an f-string for this. So I'm going to use base URL. It's going to be our endpoint prefix, and that's going to be our user ID. And now we can define the data that we want to return. So I'm going to use the JSON parameter here to define the data that we want to return, which is, for now, I'm just going to do user like this and send back the user ID. If we want to return a status code, we can do this using status. So let's say 200. And if we want to return some headers, which I'm not going to right now, we can define them here. All right, so let's go ahead and go into our virtual environment again, pipenv shell. There we go. And let's go ahead and run this test. Actually, there's one more thing we need to do. We need to provide some sort of base URL here. So I'm just going to do http://someurl.com. And yeah, okay. And because we're passing this base URL directly to our function here, whatever I use here, whatever URL I create here will be the exact one I create here. Obviously, again, it's better to have these defined elsewhere and then use a common shared parameter. But again, for the purposes of this test, we're just going to keep it like this. So I'm going to do PyTest. I'm going to run this specific test unit tests, and test sync requests like this. Go ahead and now run that. And yeah, there we go. So our test completed. And obviously, we're not going to someurl.com at the user endpoint and with user ID 0 and we're getting this response. But instead, what we're doing is in here, we're sending that request to there because this is the URL that we've created. And we've essentially prepared our test to say, hey, you're going to get a GET request to this URL. So make sure that when that request comes in, that we take that and we just return this response. So it's going to be this JSON response. This is the data we're going to return. It's going to be this status code. It's going to contain these headers. And I could mess with the status code, for example, and because we're still sending JSON data back, it's still going to work out fine because we're not doing anything with the status code right now. But here also, oops, you could also test for the status code, for example. You could test with the header stuff. So all of these are things that you can do, and you can kind of define what exactly you want to return. And in this way, we're able to test our work that requires external endpoints or external services by just mocking the response and saying, hey, when a request goes here, make sure that we return this information. And then when our function is executed and it sends this request, then that's the response that it's going to get. And then we can continue working with that. Now, the important thing here is if we're sending different requests, we want to make sure that we're properly prepared for that. So let's create a second post response. And here we're instead going to send a post here. If we're trying to use it like this instead, it's not going to work because we're not prepared for a post request. So instead, what we need to do is we need to go into responses. I'm going to add here a post. So now we're prepared for a GET as well as a post request. Now if I run this one more time, again, we're going to be fine because this is the request. So we're going to use a post method to this URL, and this is the data that we're going to return. This is the status code we're going to return. These are the headers that we're going to return. And yeah, it's just important, to make sure that when we're using these different requests method that we're properly prepared for them. So what happens now if we take this out? It still works because we're prepared for this post request. So it's very important. But in this case, for example, we will have a problem again because we're sending a post request, but we're only prepared for a GET request. So yeah, just being aware of that, this is something that can trip I mean, I've been tripped up a lot of times by this. I've added responses by copy pasting from other tests, and then I just forgot to change, like a get to a post, and then you're trying to understand why it's not working. So yeah, just be aware that different request methods require the different parameters in here. This is the URL that you're going to, and then you can just always define the values that are going to be returned from here. And then based on that, if you have a function here that does different things based on the status code, that does different things based on header parameters, all of those different behaviors are things that you can test by setting up individual tests. For example, first I want to return a 200 response, then I want to return a 400, then a 404, then a 429, then I want to return this header parameter, then I want to return bad data. All of these things are things that you can test in separate tests, and we can always use responses to them so that we're never actually going outside, we're never dependent on anything, but we know the exact response that we're going to get, and we can appropriately test for that. Now, previously we've learned how we can mock our synchronous requests and actually send back predefined responses, and now we're going to do the same thing for our asynchronous requests. So I'm going to go in here, and now we're going to write a test for this sample async get request. I'm going to change this up a little bit because I want to kind of use the same format where we have like a general URL that we have so that we don't have this hard-coded, because having this stuff hard-coded is never good. Maybe you'll actually take this from like a configuration file, but I'm just going to pass it as parameters for now. So I'm just going to have our base URL as a string. Then I'm going to have our endpoint prefix as a string, and I'm going to have our user ID here as an integer. And the URL that we're going to use is going to be our base URL. We're going to have our endpoint prefix, and we're going to have our user ID, and that's the request that we're going to send here. And now what I want to return is I'm going to return the JSON response. So we're going to await response.json. I'm going to get the status code too, and response.status. You don't have to store these in different variables, but I think it's a little bit more readable, so I'm going to do it like this. And then I'm going to return our status code as well as our JSON response like this, and just delete these print statements here. I'm going to update our just coroutine or function signature here that we're returning an integer and a dictionary. Okay, so we have our sample async get request, which is a coroutine that we now want to write a test for because we're going to some sort of outside URL, but obviously we don't want to go to that URL. We want to send back some sort of predefined response, and we're going to return some parameters, probably here do some actual like processing, like some processing code, and then maybe those are the things that we want to test actually, like the processing stuff. But we're just going to keep it simple because right now we just want to learn about how we can actually get these responses in and out. All right, so now we need to install our proper library, which is going to help us with mocking these responses. Pip env install --dev, and it's going to be AIO responses. And there we go. All right, so we're going to install this and wait for this to install. Meanwhile, I'm just going to create the appropriate unit test file, again as a separate test here since we're kind of doing separate things. I'm going to test our async requests .py. All right. So I'll just wait for this to finish installing real quick here. Should be done in a second. And there we go. So I'm going to go back into our virtual environment, pip env shell. And now in our test file, I'm going to go from sample requests, our package here, .async requests. I'm going to import the sample async get request. This one, the one that we changed. This is the one that we want to test. I'm also going to say from AIO responses, I'm going to import AIO responses, and I'm also going to import PyTests. All right. So let's go ahead and write our unit test. We're going to test sample async request works properly, like this. And we're going to define some sort of base URL. We're going to define some sort of endpoint prefix, and some like user ID, like this. and we're going to call our coroutine here. From that, we're going to get a status code, a JSON response like this by providing the space URL, the endpoint prefix, as well as the user ID. All right. Okay, and then let's just assert that our status code is 200, and we're going to assert that our JSON response, if we look at the user property, that this here is equal to our user ID. So now what we have to do is, well, first of all, we have to set this up as a proper async test, and then we have to create the mock response to make sure that when we send out this request, we properly intercept it and we send back the expected data. So first of all, to make this work properly, because we're using a wait inside, I need to make this async. I'm going to use pytest.mark.async.io like this. And now I just need to do the same thing that we had for our synchronous test, which was essentially kind of register the requests that we're looking for. Now to do that, I'm going to say with AIO responses as M. You can use anything here, of course, but I'm just going to use M because that's also what they have on their documentation. And now I'm going to register this request. We're going to do a get request is what we're sending. Our URL is going to be our base URL, our endpoint prefix, as well as our user ID. And now let's talk about some of the data that we're going to send back. So first of all, our status that we're going to return is we want to return a 200 status. I'm going to send back some empty headers for now. And the data that we're going to respond with, we have to set this using this payload property. And so I'm just going to return our data in this exact format because we're not doing anything else with it, right? We're just returning it. And now for this to work properly, I want to make sure that our request here that we're sending is in the same indent as this, as when we're registering it. And so we're using our context manager here, and we just want to make sure all of this is in the same indent level, because otherwise it's not going to capture it. All right, let's go ahead. PyTest, tests, unit tests, test async, and run this. Now we're going to get an error here, and I've left this in purposefully because I just want you to see something like that, because otherwise it may get confusing. This error is because we're importing from this library, or from this package, from this module here, sorry, or essentially because we're importing from this file, to just keep it simple, we actually have this piece of code which is always going to run because we have these functions defined, but we also have this code which is automatically going to run. And right now it's telling us that it can't connect to this address here, and that's because we're also running this function as soon as we load this file. So I'm going to turn this off. And that's kind of an important thing to be aware of. If you don't just define classes or define functions, but in your file there's actually code being just in here, it will execute. So just be aware of that. So I'm going to comment this out, and now this is no longer going to execute because these are all just functions, or in this case coroutines, that are defined for us that we can then use and run in other places. So running our tests again, now we're green and everything is working properly. Now again, the important thing here is that if this were a post request instead, for example, this is going to fail. If in this case, because we're testing for a 200 response, if we return like a 400 response, this is going to fail. If we return a 201 response, this is going to fail. If our key here is wrong, this is going to fail. So just, being aware of these things. So yeah, there we have it. This is, and I don't know why I changed this to 201 again, but this is how we can test our asynchronous requests too. Now again, the important thing here is if we're not indented on this level and we try to run this, again, it's not going to work because, well, our request is not being properly intercepted and a mock response being returned for us because we're not in that same indent level as our context manager here. So just being aware of that too. But yeah, like this, we can test our asynchronous responses by, again, registering where we're going to go and where we're expecting responses to go, and then just defining what data should be returned. Now we're using our status code and our JSON response, but obviously we can also add here, for example, our headers and then let's some header, and then we can also add this here, oops, and add another thing, oops, assert that this key is 1, for example. Let's go ahead and run that again. And, oh, sorry, this needs to be a string. One more time. And now this needs to be a string, obviously, because I changed that. There we go. Okay, so again, right now, all we're doing is we're just sending the request and returning the data, which is obviously, we're just making sure that this is working properly. But generally, when we're writing code, obviously, in these cases, getting the data is just going to be the first step, and then we want to do some stuff with it, like some processing stuff, and then we can test that the processing is working properly, given that this is the data that was gotten from the request. So that's really where it can help us out. But yeah, this is how we can go ahead and test whenever we have to send some sort of request, be it synchronous like we do here, or be it asynchronous like we do here. All right, so now that we've learned about tests and we wrote a bunch of tests, I want to introduce you to a concept called test coverage, where we'll actually be able to see how much of our code is actually being run in tests, which can give us an indication of how much we're actually testing. Now, sometimes you may hear people talking about like 100% test coverage or 70% test coverage or something, which means that much of their code is actually being run in tests. But the important thing to remember with all of this is that even with all of your code being run in tests, it doesn't guarantee that it will work perfectly because you may not have tested certain edge cases, which will still crash. But sometimes this can be a fun metric to look at. To be honest, personally for myself, I don't necessarily use it all that often because when I'm coding, I kind of make it a habit to, when I finished writing a checkpoint of code to kind of a certain piece of functionality, then I will write tests for every single function and class that I've created to make sure that all of that is covered with tests and try to think about different edge cases that you can encounter. But if you are ever interested about, doing this test coverage, then, well, yeah, that's what we're going to look at now. So first I'm going to deactivate my virtual environment here. I'm going to do pip-env install --dev pytest -cov and install this here. And this is going to be an extension to pytest, which is going to, again, let us test or let us find out how much of our code in a certain location is actually being covered or is actually being run within our tests. Yeah, so we'll just wait for this to finish installing here, and then we should be good to go to use it just a second. All right, so I'm going to go back into my virtual environment, pip-env shell. Before we actually go to this, there's a quick side note I want to take. Something that I found that was kind of bothering me is when I first started a terminal, we can go out of it using the deactivate, but actually when you're going into a pip-env shell session, because you'll see when I open a new terminal, it actually automatically activates the environment. But generally a cleaner way to exit would be using this exit command, because otherwise I've found when going in and out, it will actually cause issues with my terminal. So using the exit command is going to make it a lot nicer here, just as kind of like a quick side note here. But the thing is, if you use the exit command, the first time the session opens, for whatever reason, it just closes the whole terminal. So I've been using deactivate the first time to get out, but every time after that, you will want to use the exit command if you're kind of switching in and out. Just like as a quick side note, if you're ever experiencing any oddities in here. Okay, but anyway, that being said, we have our PyTest coverage installed now. So to look at our test coverage, I'm going to do pytest --cov, and now I'm going to say where I want to look at the coverage for. So for example, for our application code, I'm going to point that to the application folder like this, and then I'm going to do tests / like this and hit enter. And now we can make this a bit bigger. We can see here this is each of our files, and we can see how much of the code in here is actually being run in our tests. So we can see, for example, in our dependencies that here 87% of our code is being run. So there were 2 statements that were missed. Not exactly sure which ones these are. Maybe even it's some of these like variables here, but we can look at the exceptions, for example, and there we know that, well, we are using this user not found class, so yeah, that's being covered for us. Let's look at another thing, the exception handler. So again, here, all of this code is being tested by us. If we look at the routes/users, then we can see here there are some pieces of our code that are actually not included in our test. So this is just kind of like an interesting thing, and here we can see like the total percentage. So currently we have like 77% test coverage, which means 77% of the code that we've written is used in our tests. But obviously this is not a super good metric because the tests that we've written, even for our routes here, are extremely, extremely basic, and there's a lot more tests that we can write, a lot more edge cases that we can think of. But again, sometimes you may be hearing about like test coverage, and this is how we can go about getting it. All right, so we've seen a lot of different things that we can do and add to our tests to essentially test our application. And really what we want to be doing and what we want to be getting in the habit of, what we haven't really been doing so much of yet, is part of this process will also include the MyPy type checking. So we're going to do that because it's a good thing to kind of put in this testing suite, although we will actually have a separate whole section on linting, which if you don't know what that is, don't worry about it. We'll cover that when we get there, where we'll also go into this again in a little bit more detail. But, as a general just thing to think about and as a general reminder, we should generally be running MyPy with alongside our tests to help us catch any other sorts of issues. And there is actually one issue that did come through that didn't affect our program because of the way how the system worked, but we would have still caught it if we were using MyPy. So let's go ahead and run MyPy, and let's actually see what this is. So we're going to run MyPy on our application folder here. And again, I'm in my virtual environment right now. So if you're not in that, just make sure you're inside of that. All right, so this is the notes that we get from MyPy. So first of all, we have a syntax error in our type annotation, and we can click on here. And it's telling us that instead of using this format to indicate we're returning a tuple, instead the preferred format that we should be using is using this tuple here, like we also used for optional, for example, and then putting in the different types that we're going to be returning in each field. Now that's one issue that we will fix, but actually the other issue that was almost, or essentially was a programming issue that actually didn't affect us though, was this one down here. And really, so what's happening here is we had a copy-paste error of pasting the response class or the response object rather than the instance of it that we're using. So a small thing that is easy to go unnoticed that nicely MyPy was able to find for us. Now in this case it didn't actually make a difference because we're just updating the response. So it really had no effect on the running of our program, and if it would have probably been caught in one of our integration tests, or, well, in this case, because it is attached to the routes, it would have been caught in one of the integration tests. But yeah, nevertheless, that's why it's good to have all these different approaches for testing, because we want to have our unit test to kind of cover all the code that we're writing. We want to have the integration test to test the going in and going out, which also would cover this rate limiting thing. And we also want to do MyPy type checking because that will help us catch other errors, especially in some cases when we don't actually have full test coverage and there are some pieces of code that we didn't run, and because we didn't run them, there was some sort of typing issue there that we may have found if we would have ran the code, or if we would have ran it, it may have been that we set up our conditions that it wouldn't have made a difference in that case, but MyPy will also alert us to those things. So in addition to running your unit and your integration tests, running MyPy too is a really nice thing because again it will help you catch some subtle bugs that may or may not go unnoticed for quite a long time, or that may not necessarily even sometimes be an issue, but it's still obviously good to fix these things. So we fix this one by just changing this to a lowercase r so that we're returning the instance and not the class object itself. Although in this case we actually don't need to return anything, and I'm going to also change this back to none because we're actually updating the response object itself. But yeah, and so now going to the other one here, let's go ahead and quickly update this syntax into one that MyPy likes more. So we're going to import tuple from here too, and we're going to put tuple in front, and now instead of using the parentheses, we're going to use square brackets, because remember a tuple has, once we've created it, it essentially has a fixed size, and so now we can say this is going to be a tuple of two objects. The first value is going to be a list of full user profiles, and the second one is going to be an integer. Now, there are some cases also that I just want to point out that we're not running into, but sometimes you may run into this, that it will complain about using a lowercase list here. And so you may have to change this to an uppercase list and also import typing here, also import the uppercase list from typing here. For us, it's not really a problem, and for our version of Python, it should be fine. But I have seen this in some cases, and I think we were using older versions of Python for that. So just, as a kind of like side note and a heads up, in case you ever run into that, a quick change here from a lowercase to an uppercase list will usually fix that problem. But yeah, so that's again a quick kind of, well, we already covered MyPy, but a quick kind of review of just using it and just thinking about it as part of our testing suite. In addition to running all of our integration and unit tests, we want to run the MyPy regularly because again, it'll help us catch subtle issues that may go unnoticed. All right, so in this section, we're going to start learning about Docker, and we're going to integrate Docker into our application. Now, Docker is a really cool program, and I'd actually recommend you just Google download Docker or just go to this URL here, docker.com/products/docker-desktop. And for me, because I'm on a Mac, it's going to give me the Mac options. But if you're on a Windows or Linux, it will default to those, and just make sure you go ahead and download that because it's a couple hundred megabytes. So it may take a couple of minutes to download. I've already gone ahead and done this. So yeah, for Docker, Docker is really nice because it helps us solve another type of problem that we already started solving when we were talking about virtual environments. So if you remember back to virtual environments, our main motivation was that we want to make sure we have everything kind of consistent and in some sense a little bit isolated for all of the Python packages that we need. So for example, if our application needs Fast API to run, we want to make sure that everyone who tries to run our code has Fast API installed, as well as all the other things that they also need to run this application, and that it's not telling them like, hey, you're missing this installation, you're missing that installation, or they're trying to use their local installations and then there's like a version mismatch. For example, like we're using some version like, I don't know, like 10 point whatever, and they're using version like 9 point whatever, and there's a version mismatch. So all of those things are things that, we've tried to address using virtual environments. And it's great and it's been extremely useful, but there's actually more that we can do to this to make this even more consistent. And the idea here is that with Docker, we can create isolated containers. So essentially, um, just think of it like a box that we can build up from scratch, including the operating system. And we know that no matter where this will run, if we give it the proper instructions, it will look the same everywhere. And now you may be wondering, okay, why would we want to do that? It sounds a bit like overkill. Well, actually, there are certain scenarios, and I've encountered this actually myself several times, where you may install something on a Mac and it may not work properly, or it may work differently on a Linux, or things are working on a Linux one way, they work on a Mac a different way, and then they work on Windows like a third way, or you also have local things already installed that you may have forgotten because you've installed them like 6 months ago, or a year or 2 years ago, and then someone else tries to run your code and they're like, hey, these things aren't working, and it's just because there are some things that you installed that you forgot about that they don't have. And so using Docker helps us address all of these problems, and there's actually a lot more cool stuff that we can do with it that we'll look at down the line. But we're going to focus right now first on just using Docker to essentially create an extremely clean box that contains our application that no matter where you run it will be consistent. And actually Docker is used so, worldwide that when you're deploying code, you will usually be deploying that code as a Docker image that will be run somewhere. So yeah, Docker, very important for that, to really help us just get everything consistent from the base up, from having the same operating system that's running it, the same versions of our programming language, the same, and then using our virtual environments to install consistent packages. And so we just want to make sure that everything is the same no matter where you run it. And Docker is going to allow us to do that. And it's extremely, extremely useful, because then you don't ever have to worry about, oh, was there something I forgot that also needs to be installed that I have installed, or is there some environment variable that I set that I may have forgotten about, or all these sorts of weird oddities that can come up. And then especially dealing with problems like, why does it not work on your machine? It's working fine on my machine. Did you install the virtual environment stuff correctly? Yeah, you did. Okay, that's weird. Like, why is it running on my machine and not on yours? Docker is going to help us alleviate all these problems. And then, as we'll see later on, there are actually some more cool things that we can do that will make our life just a lot easier with Docker. For example, also like spinning up a database that we can use, or spinning up a cache that we can use. And yeah, a lot of cool stuff to come, but we'll focus on just isolating our application first, so that we can just give this image to someone, and then they can run it and they will get the exact same thing that we're seeing on our end. So yeah, with that, I would recommend just Google, download Docker Desktop in your favorite search engine, or go to this website here, which may change with time, probably not, but docker.com/product/docker-desktop, and then just go ahead and download the Docker version for you. Again, I already did that. And then for me, when I unpack the image, all I have to do is just drag it from here into my applications. Once you've done that, go ahead and go into your applications. And here now you want to double click on Docker and just get it to run. For me, because I've already run it before, it's just going to start running. And you'll actually see, if you're on a Mac, in the top right corner, there's going to be this little ship that looks like this, which is going to start bouncing around. On a Windows, we'll go through that in a second. But yeah, wait for this to open. It's the first time you're going to use it. It's going to ask you to read and accept the terms and conditions before the application will start. So just, whenever that pop-up comes up, just make sure you go ahead and do that. And again, on a Mac, in the top right corner, usually in your toolbar up there, which is currently off my screen, you should see a whale like this with the containers kind of circulating, which means it was starting. And once it kind of takes a fixed shape, that means it started properly. And yeah, after you have accepted the terms and conditions and the startup is starting, you should be able to go to your PyCharm. And now if you just type Docker into here, you should see some sort of output here, which will indicate that the installation has gone successfully. If you have any problems with this, the first thing I would recommend is just, first of all, wait for your Docker to finish opening. And if it's still having problems, try to restart your PC. You shouldn't need to, but it's generally a good thing to try. And yeah, then when you type Docker in here, you should see that it responds to some sort of output like we have here. So for the Windows side of things, we're going to be on the same page, and we can see here I'm already getting recommended the Windows version. Go ahead and click download on this, which I've already gone ahead and done because it takes a couple of minutes to download. Then you're going to open up the installer. It's going to prompt you if you want to open this. You're going to click yes. And then we're going to open up the installer. There's going to be two checkboxes that are going to be by default checked. Just leave those and click next. Then the installation is going to start, which again takes a couple of minutes, so I've just kind of let it run in the background. And yeah, this is the stage that you're going to reach where we'll say the installation has succeeded. And then we're just going to click close and restart. So we're going to restart our machine for this. So after restarting, on the Windows side of things, we're also going to get prompted with this pop-up here. I'm going to accept the terms and just continue with that, and now Docker is going to open. In case you get this pop-up too, we're just going to follow some more instructions here to get the installation process. So let's just quickly go ahead and do that. Move this out of the way, follow the instructions here, download this here real quick, open, execute, and just go through this process. And then I already have PyCharm open here. We're going to take this, and I'm just going to copy it, go into PyCharm, which already has the PowerShell open, paste this in there. Just going to hit restart one more time. And after hitting restart here, if we go onto our Docker, we should now be seeing that Docker desktop is starting. If we open this application, if we go to the bottom right, then also there, which for me is currently off screen, but there also you should be able to see, if you click on this like little Windows arrow that you always have, that you have this Docker ship thing here, and then you have the containers that should be moving, and also there if you click on it, then it should take you back to the Docker application, like we have here. Okay, so now going into our PyCharm, if we type Docker in here, then also from the Windows side, this command should now be registered with something, and we'll see in a second. Now we have output associated to it. So this is how we're going to go about the installation process on Windows. All right, so now that we've got Docker installed, let's go ahead and actually use Docker so that we can run our application over it. Now, before we jump into that, I quickly want to show you just in general where we're going to get these base operating systems or these base pre-installed packages from that we're going to use. So to do that, you can head to hub.docker.com. Now you're going to need to create an account here, so if you don't have one, just go ahead and sign up for that. And then you can sign in, and you'll get to a page that should probably look something like this. And you can either head to the Explore section if you'd like, and here we can already see a list of different kind of base systems that are available to us. These may or may not mean anything to you, and we can see here Python is one of those. So we can either click directly into this, or if we're looking for something specific, we could also search up here, for example, Python, and we're going to be using a version of this. And when we see in here, we can see that there are essentially like tags associated to them. And we'll see in a second how we can use these, but all of these are essentially different versions that we have access to that we can use. And the importance of using tags is it provides us a sense of consistency. If we use a tag, we're able to consistently kind of reuse the same thing, and that way even if like upgrades are put out or something like that, we know that our system is not going to change. It's always going to be running under the exact same conditions, which is obviously so important for us. So for us, I'm going to be using the Python here, but just for your information, that if you ever need to use like different base or images, then if you're not sure what exactly you're looking for, a quick Google or using your search engine of choice will probably very quickly point you in the right direction. But otherwise, you can also just browse what images are available, the public ones, by just going to the Docker Hub. And you'll see here, for example, for Python, this is an official image, and that's usually a good tag that you want to look for, since those are generally the more trustworthy ones, since this is going to be kind of forming the base. And so you want to make sure that what you have installed is like a proper version and not just made by some random person that may be a little less trustworthy, although the gray line at that area also becomes a little bit questionable, what is trustworthy and what is not. But generally as a good indicator, the first thing is look for the official images, and when it doesn't have that tag, just make sure you understand what you're using, since it's what you're going to be running your application on. So just kind of being aware of that from like a security perspective. But that being said, let's go back to our application. And what I'm going to do in here, I'm going to create a new file, and I'm going to call this Docker file, like this, uppercase D, Docker file. I'm just going to hit enter. And now in here, we're going to create our Docker file. So the first thing that we need to do is we need to specify what should form the base of our system. And so essentially the way that we will go about creating these Docker containers, which you can kind of think about, we are shipping these well-structured, packaged, isolated containers, almost like in a shipyard, and each one of these containers will contain, in our case, like an application, but it can really contain anything that is, in in its sense, like self-sufficient, or at least has everything included that needs to be included within this single package. So yeah, the first thing that we need to do is we need to define what our base is going to be. And so we need some sort of like operating system base, but generally, if we just start from an operating system, it becomes annoying because then we need to install all the like extra Python dependencies to make sure that we can run Python. And so a much easier thing for us to do is, rather than just starting at some basic operating system and building up from there, we can go a couple steps further and we can start with an operating system that has Python installed, and then all we have to do is install all of the stuff that we need and essentially run our application. And so that's what we're going to do. And so we're going to start off with this from keyword, which is going to define where we want to start off with. And so I'm going to be using the Python image, and specifically I'm going to be using the tag 3.9, which, as you may have guessed, indicates that this is for version 3.9 for Python. And then I'm also going to add another dash here and do the Alpine image. Now, the Alpine image is generally a nice thing to kind of start building off of because it's relatively small. The thing that you don't really want is you don't want to install a massive operating system that has a bunch of things installed where you're not going to be using a lot of it. And so generally the Alpine image itself with the Python will be enough for your use cases, but if it ever is not, there's another thing called Slimbuster which you can try out. But alternatively, a quick Google or a quick using your favorite search engine, whatever that may be, will very quickly point you into the right direction of what may be a better image to use for this. But for most cases, the Alpine image will be sufficient for you. And again, the benefit that we get from it is that we're not just installing a bunch of stuff and that our container becomes very big, but rather we want to keep it as small as possible so that we're not using up a lot of our system resources just to have all these things installed that we're not even using. So yeah, we're going to start from the Python image using the tag 3.9-alpine, which again is a Python 3.9 version, comes with all that and the dependencies pre-installed. And we're using the Alpine version here since this one is relatively small. All right, so this is the first command that we have, which is the from command. Now we're going to look at the next command, which is going to be a run command. And so here we can use these commands to initiate certain steps. And the way that we go about things in Docker is every single command that we have, or every single keyword that you're using here, you can imagine you're adding another layer onto your image. So we have our first layer here. Now when we have our first keyword here, run, which we'll see in a second, we're going to form our second layer. If we have another keyword here, let's say another run, that's going to form our third layer. And with this, we're kind of building layer upon layer upon layer. Now, the reason that this is nice is because Docker actually also has some form of caching. So it will recognize if you haven't made any changes for like half of your stuff and really only the last step is the one that changed, then it can reuse most of the stuff from previously and it only needs to change the last layer. So keeping that in mind is a very important thing, just because when you're building your Docker images, really the things that barely ever change you want to put at the very top, and the things that can change more regularly, for example, the packages that you need to install, or also just your application code, all of that should be more towards the bottom. All right, so starting with this run command though, here we can tell Docker to run a specific command, and you'll recognize this. We're going to run pip install pipenv. So we're going to be running this command here, which you probably recognize from an earlier lesson, where we're going to be installing pipenv using our pip. And we have pip available because we're installing this Python base image, which already has Python as well as the things that we need for it. All of it is pre-installed. So our Python version here is going to be 3.9 again, and we also have the pip command that immediately comes with it. So yeah, we're going to be installing our pipenv like this. Now, another thing that we're going to do is we're going to create a new directory, or we're going to create a new folder where we can keep all of our stuff. Because ultimately, we're kind of creating this container, and we want to put everything that we need in one location so that it's available for us just like we have it here in our project file, for example. And so to do this, we're going to be using this mkdir for make directory. And we're going to have this -p, which essentially allows us to create multiple folders at once. And then we're going to just use this path, user src/app. And this is where we're going to be putting all of our code for our application. Now, this stuff, I don't want to get into too much detail with all the Linux commands because there's actually a separate course about that. So, don't want to derail off a little bit too much here and just really focus on this, but essentially kind of keeping in mind here, and you can just, reuse the syntax, is we're just creating this directory here, and we're kind of creating these folders. So in the user folder, we have the src folder, and in there we have the application. And if any of these don't exist, we're going to be creating it. So we're doing this again just so that we have a folder that we can put our stuff into. The next thing that we're going to do is we're going to use a new command called workdir. And this is going to set our current working directory. So this is going to help us because rather than always having to type this everywhere whenever we want to run something, or in a second we'll see copy something over, we can just say using our current location. So it's just going to make it a little bit easier for us so that we don't have to repeat this here the whole time. So we're going to be setting it to this, user src app. This is going to be our working directory, or kind of the folder that we're currently working in, that everything should be relative to. All right. So now we have pip installed, we have the folder that we're going to put our stuff into, and we're also going to be just setting our relative location to this. Now what we need to do is we have access to our files, but we want to copy them into our image and put them in the right location. So we're going to use this copy command. And now we need to look at what we have here, and essentially we want to now copy this, and we want to have the same structure for the most part here, except maybe getting rid of some of the junk that we don't need. So we're going to do this in 2 steps. We're going to start with the pip file lock and the pip file, as well as this main.py, since these are kind of the ones that are more outside, they're kind of one level above. So we're going to be copying these over. So we're going to copy our pip file, our pipfile.lock, and we're also going to be copying over our main.py, and we're just going to use this because rather than having to write out the full path, user src app, where we want it copied into, because we've set our working directory, we can just use the relative path, which means copy it into the current kind of working directory. So that's going to be taking this, and it's going to be copying that over for us. All right, so now that we have these files copied over, now we want to copy over everything in our application folder here. Now, unfortunately, we can't just add our app here because it's going to take all the contents from inside and it's just going to copy it onto the same layer, which is not what we want. So we're going to add a second copy step here, and we want to copy the contents of our app into essentially an app folder. So what I'm going to do is I'm just going to create another app folder within here. So our folder structure is going to be, our top folder is the USR, then we're going to src, then we have the app folder, and inside here we have another app folder. So you can imagine this by just, if this folder name instead of being our first Python project would be app. And we have app here and app here. And now I wanted to copy the contents of this folder, which is app, into the app folder found within here. All right, so we've copied over our first level stuff here. It's going to be on the same layer. And now I want to make sure that all the contents in here are also in this sort of format. And again, if I just used this, then it's going to take the contents from here and it's going to copy them onto the same level, which is obviously not the current structure that we have. So to do that, I'm just going to add another folder here that we can copy that into. All right, so now that we have this, let's go ahead and for now, just learn how we can start our image and look at our current structure to make sure that that is okay. And then what we're going to do is we're going to finish with the rest of the stuff, which is going to be installing using the pip-env install and also actually running our server. But for now, let's just look at our current structure and see that it's proper. And for this, I'm going to use the ls-l, which if you're on a Mac or Linux should work for you. I don't think this will work on a Windows, but that's okay because it will work in here because we're going to be using a Linux-based version anyway. But you can see what this command does is it prints out the contents contained within the current folder that I'm in. And so essentially we can see here the contents here are exactly like the contents listed here. So I'm just going to run this for now, just so that we can get a look into our image that we're building here to make sure that our structure is correct. All right, so now that we have our Docker file defined, which defines the set of steps that we're going to take starting from a base image and copying all of our stuff over to, having this image that contains all of the stuff that we need so that we can actually run our application. It doesn't have everything yet, but we're getting there. So now what we have to do is, now that we have this image defined here, we need to build this image. So we need to run these commands and put it all into a ready package that we can just run. And so to do this, we're going to use the command called docker build. And now we're going to use a -t here, which is going to be the target that we want to copy this into, or the kind of the name that we want to associate to this. And so here I'm just going to call this my first app, and I'm going to give the tag twist latest. Now latest is a tag that you'll very often see, which is, it just indicates that this is the latest version of this image. Now usually what you'll have is you'll have a tag associated to each image, and then you'll also have a latest tag. And so that way, if you just want to run the latest version, you can use the latest tag, which will probably change with time if updates are being applied. So that way you're guaranteed to always be on the latest version. Or you could also reference a specific tag like we're doing in this case here, which means that even when Python 3.10 is out, so it's 3.11, when 3.12, or 13 if that will come out, or when Python 4 will come out, that's not going to impact us because we're still going to be sticking with the specific image that is labeled with this tag here. So it guarantees consistency for us, that even if things around it change, we're always going to be using the same base. So obviously there are pros and cons to each. With this, you can easily stay up with the latest version whenever you're starting it or rebuilding it, but obviously there are also caveats, because if things change, they may become incompatible, and then your stuff may no longer run, which is obviously not good. So keeping that in mind. So now we have the target that we want to build this into. Now we just need to give the location of our Docker file, which I'm just going to put the dot here, which is just going to indicate it's in the current folder where we currently are at. I'm going to hit enter. Now for you, this is probably going to take a little bit of time, since you need to first download this image and then you're going to run all these commands on top of it. For me, a lot of this stuff has already been cached, and you can see here, if we scroll up, a lot of these steps have been cached, and so there's no re-downloading being done for me, and the building process actually goes very, very quickly, as we can see. Once you've run this the first time, if you run it again, then also it will go very quickly, because again, these layers are cached. So now that we have our image created, now we want to run it. So we have this package that's ready, and now we want to run it. And so to do that, we're going to use the docker run command, and we're going to provide now the name as well as the tag that we want to run. So we want to run this image here. And I'm also going to assign a name to it. So we're going to be running this, and this is going to be running as a container. We're going to be running this image here as a container, and we're going to give a name to this running container so that we can, better see it. That we can, when we're looking at which things are running, which we will look at in a second, we will know, oh, okay, this is that one. So we can kind of give a readable name to it. So we'll call this our maybe underscore first, application. You don't need the underscores, but I'm going to use them. And yeah, just hit enter here, and we're going to be running this. And we can see it executed this command here, which is just listing out the contents, and the structure that we have is pip file. We have pipfile.lock. We have the app folder, which inside should contain all of this stuff, and we have the main.py. So this is what our current folder looks like that we have. Now this is nice because we don't have the tests, for example, because we don't need the test if we're, running our image or if we're running this code as an application, because by then our tests have run and we no longer need the test there because we're not going to be running the tests as a live application. We're going to be running the tests when we're testing locally. We're going to be running the tests later on when we're, before we build our image. But once our image is built, we no longer need the tests, and so we can discard that and save ourselves just a little bit of space here too. So now that we have this running, let's go ahead and continue with our setup here, because really we don't just want to like print out the contents and then be over and done with it, but rather we want to have a running application that we can actually use. So to do that, we still need to take a couple of steps. The first thing that we need to do is we need to run our pip install so that we're installing all of the dependencies that we need. So we're going to use our pipenv install. We're not going to be using the dev tag because this is going to be our production image essentially, so we don't want to install the development dependencies because we don't need these. This is going to just be our pure application. However, we're going to use a new tag that's going to be -- system. Now this is going to install everything that we're using system-wide so that when we're running it or when we're trying to access it, we don't have to go into our virtual environment, but it's just going to be installed for a whole system, which is going to make it a little bit easier for us because then we don't have to use the pipenv commands later on again, because essentially what we have in this whole image here is one virtual environment, right? We're recreating this every single time, and there's nothing else kind of going into it. So we can install this system-wide because we know exactly what it is because we're building everything up from scratch. So we're going to be installing our dependencies like we usually do. And now what we need to do is we actually need to run our application. So we'll use the cmd command again for this, and we're going to open and close parentheses, and each of the entries or each of the elements that we'll have here is going to be one of the arguments that we're going to run. So for example, usually when we run unicorn main-app, which you can actually run like this, but the preferred way of writing it would be like this. So if we just do this, this is going to be the usual command that we use, except usually we also have this reload tag. We do not want to use this in production because this will heavily slow down our application. So make sure that you don't use this tag in production. When we're running it locally, it's fine, it makes our process a lot easier, but when we're running it in production, we no longer want to use this tag. So right now we can just, keep it like this if we want to. And we can try it out, but there are still some issues that we'll see in a second with this, but let's get to those when we get to those. So what I'm going to do is I'm going to, again, rebuild my image. I'm going to go into my first app, latest, so I'm going to be overwriting that tag using the docker build command. And, oops, forgot the -t here. So in this case, it's going to be taking a little bit longer because now we actually need to run this pipenv install system. So previously we didn't run this, but now we are running it, and so it needs to actually run this process. It needs to download and install all of the dependencies, and so this time it's going to be a little bit slower, but we can see all the previous steps here were actually cached, and so they go very, very quickly. And once this is done, which it should be done in just a second, yeah, there we go. So now that we have this built, we can go docker run, and we're going to give our name, which is going to be my first app, latest, and let's reuse the same name, which is going to be our first application, and we want to give the name tag here. So we're going to be running into an issue here because, it's complaining that this name is already in use, and we'll get to this problem in a second, but for now, let's just use a different name, for example, like this. This name is now different than this one, so it should be fine. But we'll get to this issue in just a second. So let's go ahead and run this, and this is going to be, we can see here the kind of command that we've usually seen, which is our application is starting up. But now here's the thing, if we try to access it, like we click on here, we don't actually have access to it, which obviously sucks because ideally, even locally, we want to be able to actually use Docker to do our development, and that way we can be extremely sure that what we have running locally on our machine is exactly what's going to be running in the cloud later on. And we're not going to run into any issues of things not being properly installed, things not being available. So that's what we're going to look at now. All right, so I'm hit here Control C to kill it. And now what I'm going to do is, first I'm actually going to use this -- host tag. So rather than running it on 127.0.0.1, instead I'm going to run it on 0.0.0.0, which just means that this will accept any interface that we're coming from, which just makes it more general, which is again nice because we don't want to specify a specific address, but essentially we just want to make it as long as we go here, we want to have access to it. So we're going to be using this host instead. And now also what we're going to do is we're going to define a specific port that we want to use for consistency. So I'm going to be using port 8080 here, for example, but you can use different ones too. But yeah, for this case, I'm going to be using port 8080. And now if we rebuild our image, I'm just going to scroll up and rebuild and wait for this process to finish. You can see most of our layers are cached because the only change that we made was actually here. So everything else has already been done, and so we essentially reload all those steps from a cache. And now I'm going to just assign a new name for now, since we had that name collision previously, which we'll look at in a second, and hit run. All right, so now we can see here we're running on this host and we're running on this port, but still, if I go here, we still can't access it. And that's because our application is running within this container and it currently doesn't have access to the outside world, even on our own machine. So what we need to do is in our docker run command, I'm going to use the -p flag, and it's going to allow us to do port forwarding. So when we go from our machine and we look at it from our port, it's going to forward it to a specific port in our running container. So for example, I'm going to say forward port 8080 to 8080 in the container. And this way now, when I run this, that name already exists, right? We have to change this name for now. When I go here, now it's going to be available. And we can see if we go to the docs page, we'll have the docs available for us because we're on port 8080, which actually now gets forwarded to the container port. Now to show you this again, let's use some different numbers here. Let's use port 8000, which we're going to forward to the, that's not what I wanted, 8000, which is going to be forwarded to port 8080 in our container. So remember, in our container, our application is running on port 8080, but outside we're going to be forwarding it from port 8000. So if I run this, I have to update the name again. Running it, if I click on here, now we're going to have an issue because there's nothing running on port 8080, but if I use port 8000, then we're going to be forwarded to port 8080 inside our application. So this is an important, I'll show the command again. This is an important step that we need to take because we're going to be forwarding what we have on our machine actually and allowing us to go into the container. All right, so now let's get to this naming issue here. If we use this command, docker ps, we can actually look at all current running containers, which currently there are none. But if I run this one again, the name again. All right, if I run this one again, and I open up a new terminal here, and just wait for this to finish preparing. And I'm going to go out of my virtual environment. Now if I use the command again, docker ps, we can see here we have the one running container. We can see here this is the command that's being run inside. This is the port forwarding that we have going on. This is the name of the running container when it was created, the status we have to it, the image that it's running, and as soon as we kill it, you can see here now it's also gone. But if we want to look at all containers that are available, and we'll go back to our previous terminal, we can use this docker ps -- all, which will show us all of the containers we have. So we can see here, this is the first one that we created. Then we have the second one, the third one, the fourth one, fifth one, sixth one. And so what we can do is if we have these old containers, rather than just sitting there taking up space, we can actually delete them if we want to, which we can do using docker remove. And then we're going to specify the container ID here. So I'm going to hit enter, and it's going to remove that. So we can see if I print it out again, this one is now gone. And I'm going to do this for this one too. And let's also do it, oops, let's print out these ones again here. And to make this a little bit quicker, let's remove multiple. There we go. Printing those out. Now we can see we only have our application 5 left over, which also is no longer running. So if we want to delete this one, we also can. Docker remove. So now we have no containers. And now if we go back to, for example, our run command, we can reuse the same name because there's no container that's currently associated to it. So now again, it's going to be working. There's still some other commands here though that you'll probably be using. One of them, and what I'm going to do here is I'm just going to chain two commands together. So I'm going to, actually first I need to get this container ID, and I'm going to remove it. All right, so we'll look at that in a second, but first, one thing that we'll probably be doing is what we don't want is don't want our terminal to be kind of blocked by this, because we still want to be able to do other stuff. So there's a flag that we can use, which is this -d, which is going to run it as a daemon process, which means it's just going to be running in the background. It's not going to be taking out this foreground terminal space. So if we run this, we can see here now, if we do docker ps, we have a running container. And if we go to our web browser, I hit refresh here, then we can see that our application is in fact running. These were the other ones, so I'm just going to close these. This one should also not be running because it's the wrong port. Yep. So now it's just kind of running in the background. So now the question may be, oh, okay, so how do we stop it from running? Previously, we could hit Control-C. What we can do now is we can use the command docker kill and give the container ID, hit enter, and now if we try it again, our application is no longer running. We can see here no running containers, and we still have the container available though. So I'm going to remove this one like this, and we can also do this using the desktop UI if we want to. So if we pull this one up here and we now run our container like this, we go back to the UI, we can see here now we have a running container. If we want to, we can click into it. We can actually see the output here. There's like, some stuff that you can play around with if you'd like to. And whenever we're ready, we've seen how we can just do this over the terminal. If you do want to use the interface, if you want to stop it, for example, you can hit stop here, which is going to stop it from running. So if we have docker ps, we can see there are no running containers. If we do docker ps -- all, you can see the container is still available though. And if we hit delete here, for example, then we're also going to be deleting our container. So this was our first look at Docker, and I know we've covered a lot, but we've gotten to a really nice point because now we can actually run all of our code, well, except for making changes at which point where we still have to rebuild, but we can really run our application over a Docker image, which is awesome because this is going to be the exact specifications that it's going to be running in when it's running in a cloud environment somewhere. And so we know whatever is running here is essentially how it's going to be functioning when it's running somewhere else, which is extremely great because now we have a lot of this consistency in our system, and we don't have to worry about, okay, but it runs on my machine, will it really run somewhere else? If we're using Docker images, then we know that even if we want to give this to like a colleague, they can download it, they can build the Docker image, they can run it, and they're going to be seeing the exact same things that we have. Now, obviously, Docker is a very cool software, and there's a lot of stuff that comes with it, and we're not going to cover all of it. And we're also going to be looking into Docker Compose, so there are some things that we can do in Docker that we're not going to be looking into here, because some of the things we'll be doing using Docker Compose, for example. But even with that, obviously, there's a lot of nitty-gritty stuff that you can get into to do some really like fancy and complex things to really have a cool system. But for almost all intents and purposes, what we're doing now is essentially what you're going to be needing and what you're going to be doing when you're actually building and running applications in a company. And if you do ever need specific things or run into specific issues, then Google or whatever your favorite search engine is probably just going to help you out the quickest because you know exactly what you're looking for, the base things of what you can do, and then you can just quickly alter some stuff around. But yeah, Docker, again, is very, very important, very, very common thing. All of my code that I'm running essentially will be running with Docker in some way because it's just so nice to have that consistency of having this image that we can just deploy somewhere and I know exactly how it's going to work, and you can give it to a colleague and they can run it on their machine, and you know that whatever they have is going to be the exact same setup that you have. And so it's just really nice because it allows for consistency and reproducibility. So previously we've seen how we can create our Docker images. Now in this lesson we're going to go over some best practices and adaptations you can do to this Docker image that we're creating, or this Docker image template that we're creating to build a container off of. And yeah, essentially this is stuff that you'll very likely see used in many, many places. And just in general, or first of all, as a quick side note, you'll probably see if you're using PyCharm that you're going to get some sort of like plugin install request for Docker. And if you want to, you can just hit install plugin. It'll be like a blue bar, and it'll just add some like formatting, as you can see me having it here. But if you don't want it, you can just click ignore. But just as a quick side note, you'll probably see that pop-up bar. But anyway, so for these improvements, you're going to see this generally a lot. And what we're going to look at is we're first going to create a user. So this user is going to help us because we don't want to run our whole system as a root user in the end, but instead if we run it as like a user with reduced privileges, that can help us because if our Docker image or our Docker container ever gets hacked, then that user that hacks it is not going to have full system access, but it's going to have reduced access, which is nice. The other thing that we're going to look at is multi-stage builds. And this just helps us reduce the size of the final image that we have that we're going to run, which just helps keeps things smaller. So yeah, and just as a general note, for this Docker stuff, we're going to go through this kind of step by step so that you understand what we're doing, but most of the time you're going to have some sort of template. If you're working in an organization, you can probably be pretty sure they have some sort of Docker template that you can use to work off of. If they don't have like an official one, you can just look into another repository and use that as a template and kind of adapt it to what you need. And alternatively, like if you know what you're looking for, there's a lot of templates online too that you can use, so you don't have to memorize this stuff by heart. You're going to be probably using templates for this. You just kind of need to know what you want, why it's there, and if there's anything missing, add that in essentially. So that's why we're going to go through it from the ground up. But most of the time when you're doing this, you can write it yourself, but it's also just easy to like use a template because most of the time you're going to be doing very similar things. All right. So let's start off by adding our user. So we're going to add another run command here, and we're going to do add group -s to add this. We're going to create a group that we're going to add our user into in a second. We're going to add that to our system, and I'm just going to call this group my app, but you can call it whatever. And then we use this and, which allows us to chain commands together. So first we're going to execute this one, and now we're going to run another command after this one, which is going to be add user. And we're also going to make this add this user to our system. We're going to add it into our my app group. We're going to give this user the name user, and we're also going to assign an ID for it. Let's just do 1, 2, 3, 4. And now if we want to run everything as our user, we're going to use this docker user command, and then we can either give the name here that we've assigned, or we'll see in a second, we can also use the ID. And what this is going to do is it's going to look up this user in the system, and it's going to find its ID, and then the next command or entry point that we have, it's going to run using this user instead, which is nice because then we're no longer running this as the root user that has kind of full access, but instead with reduced access. So let's go ahead and make sure this runs. We're going to first docker build -t, we'll do my app latest, and I'm actually also going to use this and here so that you can see what it does. But essentially first we run this, and if this is successful, then we're going to run the next thing here, and that's going to be docker run. Let's assign it a name, my app test, and we can map the ports like we learned previously, and the image we're going to run is my app latest, which is going to be this one here. Hit enter. Now this should go relatively quick because things should be cached, and we only added 2 more commands at the very bottom here. So we can see here the building process went very quick, and there we go, we're running, and it's running properly. So excellent. All right, let's go ahead and shut that down, Control C. And yeah, go on to the multi-stage build part. And here we're going to add some more changes, which we'll see in a bit. So the first thing that we're going to do is we're going to keep this from command, but we're actually going to assign an alias to it, and we'll call this our base. And in here, we're essentially going to be doing our installation and our setup, and then in a little bit, as we'll see, we're going to copy things over from this base that we've created into our main running image. And now everything that's not going to be the latest one that we're using is only going to be temporary, and then it's going to be discarded, which is nice because that means everything that we don't pull into our final image will be discarded and it won't take up any space. All right, so we're creating our base image here. So now the first thing that we want to do is we want to install pipenv, and now rather than because the first thing that we want to do, or the whole point of this base image, is essentially we want to install some of our stuff. So what I'm going to do is I'm going to take this here, I'm going to cut, I'm going to put this over here. But I don't need the main file right now because I just want our pip file and our pip file lock because I just want to do the installation. So I'm going to just, for now, create an extra copy command down here, and I'm going to take this part and move it down here, and we'll kind of get to this later. So right now I'm just going to copy our pip file and our pip file lock. Alternatively, what we can do is use pip file star, which is going to look for anything that matches this format, so anything that has pip file up front, and then any file that has anything after that. So this is, for example, going to match pip file and pip file.lock, and if we had another one like pip file 2, this would also get matched by that. But this, oops, nope, didn't want that. We can use this or the other one, but this is kind of just a shorthand. All right, so we're copying over our pip file, and now the next thing that we want to do is actually run this installation, because we want to run this, create it in our base image, and then we're going to copy over the installed file so that we don't have anything else. All right, so we're going to keep a similar syntax, but change things up a little bit. So we're going to keep our pipenv install. We're going to do a system-wide install. We're also going to add another flag here, which is going to be the deploy flag. And if you want to know what these flags do specifically, we can, because we have pipenv installed, we can go pipenv install -h. And this is actually going to pull up a help lookup, which will give you all the commands that are accessible. So we can see if we go to the system, for example, is going to be, we're going to install this just on our system, our deploy. So this is going to be good because essentially if something is wrong, like our lock file is out of date or our Python version is wrong, it's kind of going to abort, which is good because, we just want to make sure that everything is running as described. And so if something is wrong here, it's just going to abort. And then we're going to add another flag, which is going to be ignore pip file, oops, which means we're going to build specifically from the lock. All right, so this is going to be our pip install, which is a little bit different, but still very similar to what we had before. There's still some changes that we'll need to make here in a second, but we'll get to those when we get to this. Now we're going to add another from, and we're going to pull from the exact same image here. And then here, now we're going to, well, we want to copy over the things that we have previously installed here so that all of the packages that we installed are copied over into our main image that we're going to need. Now, to do this properly, there are several things that we need to do. So first of all, we're going to add some environment variables, which actually for Docker, we can just use this env keyword, which is going to set environment variables for us. So the first environment variable I'm going to use is going to be our pyroot, and I'm going to define it to have this /pyroot value. And this is essentially going to, we're going to use this in a second to say where we want things installed to. Then we're going to create a Python user base variable. Now this variable is important because it tells us, or it tells the system, the base directory for the user. And we're going to set this value to this pyroot environment variable. And I can reference the value contained in this variable by using the $ and then the variable name. And if I want to, I can also put this in square brackets, which can be helpful if there are other things attached afterwards. So now what we've done is we've defined this environment variable to this value, and we've defined this environment variable to the value contained within here. Now we're going to use one more environment variable, which is going to be the path. Now what the path is essentially a list of places where our operating system will look for executables for. And because we're going to be installing into this directory here, we want to make sure that we add this into the discoverable list of files to look for executables for. So to do this, we're going to reference our existing path variable, and we're going to add onto it our pyroot /bin directory specifically, because this is where our executables are going to live. Now again, like I mentioned previously, you don't have to understand this like inside out. You don't have to be able to reproduce this by memory. The point is that you understand why we're doing these steps. Here we're adding this because we need to have some sort of base user directory where our installs are going to go. And now because we're adding installations, we also want to make sure that the executables can actually be found by our operating system. So that is essentially the steps that we're taking here. And if we don't take these steps, you'll see, and we can try that in a second, it's not going to run. So it's important for us to add these steps so that it will run properly. And yeah, all that we're doing here is just creating environment variables. All right, so we have our pip install pipenv, which we're going to keep the same. So we still want to install pipenv. We're going to copy over our pip files. And now we're going to add one more flag in front of here where we're going to define our environment variable for this command. And we're going to set pip, the user environment variable here to 1, which means it's going to treat this installation as a user installation, which means essentially the user location stuff that we defined above is now going to take effect. So we've just updated this to now treat this as a user installation. And this is the first part. So this is what our base is going to consist of. And again, the purposes here is doing the setup, and if you ever need to install any other dependencies, you would do this in this base component. So installing everything that we need that we can then use to install other things. All of that stuff is going to go in here. Now we're going to have our second Docker stage. And here we're actually going to put our final image together, and we're going to take over what we need from here, and everything that we're not going to take over is actually going to be discarded at the end, which is nice because that saves us a bit of space because we are not taking over unnecessary things. So we're actually going to define these 3 variables exactly the same way here. So I'm just going to copy these over. Now the next thing I'm going to do is I'm actually going to take this user command and I'm going to move this up here because when we're doing our copying in a second, I actually want to make sure I assign these files specifically to the user. But before we do that, we're going to have a copy command here because we first want to get all of our packages that we've installed with our pipenv over into this image now. So I'm going to use the chown, and here we're going to define the group first. So the group here is my app, and this should be an equal, not a colon. The colon goes here. So this is going to be the group, and this is going to be the user. And we're going to add another flag from base. This base references this alias that we have up here. And now we're going to copy over the contents from the pyroot directory from our base into our pyroot directory on this image here. So essentially we're copying over now all of this stuff that we've installed here with the pipenv install. We're copying all of those packages over because we need them, because we need those things installed to run our application. And this command, or this syntax here, is a special thing that we can add for Docker, and it just means copy this over and assign the privileges for these copied things to our user here. And this is where we want to copy from. All right, so now that we've copied over all of the packages that we need installed, I'm going to keep this here because we're going to keep our directory. I'm going to keep our assigning of the working directory, and rather than just copying these directly, I'm now going to copy them with privileges assigned to that user, like this. And yeah, that is it. That is it. So this is our updated Docker command. And let's run this to make sure it works, and then let's go through it one more time. So I'm going to, first, I need to remove the image that we ran previously, which is, yeah, this is the name that we assigned to it. So I need to remove this one first. And I'm actually going to use this and again here. And what I'm going to do is, because this helps me run it several times if everything passes, I'm going to remove the image I created previously. This only works obviously if I've ran these two commands first. But once I run this Docker run, and I just want to run it with the same name over and over, I'm going to remove that existing, sorry, not image, I'm going to remove that existing container. I'm going to build a new image from our Dockerfile template, assign it the same tag. I'm going to run this image as a new container in this name. So let's try that. Okay, so we can see here we have two different stages also happening. We have a base stage and we have our kind of final stage. And there we go. Our system is now still running, thankfully, but we've integrated some Docker best practices. We are now not running as the root user. Instead, we are running as a user that we've created with reduced privileges. And there's also a step here, which for us probably is not going to have that big of an impact. But once you need to install like other binary things to help you install other libraries, like first you need to install something so that you can install other things. It will help you because those things that you installed previously, once you've installed your library, you may not need them anymore. And so this process is just going to help with that, because essentially a lot of the setup stuff that we may need to install but may not actually need after the installation is complete, we can discard all of that. So everything here that we're not specifically copying over in this final stage here, currently this is our final stage, including this, all of this here that's not copied over into here will be discarded. So that's just going to help us again save some memory. And yeah, this is multi-stage building with a additional or running things as a user. We can also change this instead to use the user ID that we've assigned to it here. And let's run that again to make sure that this still works. But yeah, if you look up Docker templates, both within an organization or also online somewhere, they're going to follow a similar kind of format like this. They may have some differences somewhere, but this is going to be the kind of main goal. Is you have a base image, and you'll often maybe sometimes also see like a base image, then you'll see a builder image where the building process actually happens, and then you'll see the final image where the things are copied over into. So there may be even more than 2 steps involved, but it's the same idea of doing the setup and then copying over everything that we need and discarding the rest to just make our final images a bit smaller so that we're not using unnecessary memory in our images that, we don't want things installed that we're not going to use is the whole point of all of this. All right, so yeah, there's one more optimization that we can do, which I'm actually going to do. Right now we have 2 stages here, and generally a good goal to have is have as few stages as possible. So what I'm going to do is, instead of having the main.py outside, I'm actually going to move this into our application here, like this. Copy this over. And in our main.py here, yeah, we still have our application defined in here. And I don't think we need to actually change anything in here, which is great. But now in our Docker file, we can now essentially remove this. We can also remove one of these apps, because now everything is going to be contained within our app folder here. We can remove this app too, if we want to, or alternatively, we could leave this in and just do it like this. And let's build and run that one more time, and hopefully I've updated all the references correctly. Now it's going to take a little bit longer because we've made some changes into our code here, and so at some point before the copying, okay, let me quickly find what is going on here. Main.py. Oh, I think this is let's try it like this. And now I need to update my entry point here because our working directory is 1 level up. So I need to make sure I go into this folder and then run it from there. Yeah, one more time. Third time's the charm. All right, there we go. So with the steps, we were able to reduce our number of steps that we have in our Docker file by 1, which is nice. And essentially, we just had to, change up some of the files that we created and some of our name references here to make sure that everything is in the right location, that we're referencing it from the right place. So now we are essentially on this level. Here we are going into our application folder, into our app folder. We're referencing the main file, and in here we are still referencing this app, this initialized app that we've created here. So the process is still the same, but we've kind of put it into one thing here. We've reduced our steps by 1, which is just nicer. The less steps you have, the better it is. And that's just a general good thing to aim for. Now, before we wrap up this lesson of Docker best practices, I actually noticed we also want to add our pip user equals 1 flag here, because we want to make sure that all of the installations that we're doing are actually going to be with the same user level, so that we're not getting some things installed on our system and some other things installed on our user. All right, so previously we've taken a deeper dive into this Docker file and have restructured it in a way that's kind of nicer, following best practices. And now we're going to take a look at Docker Compose, because currently when we've been using Docker files, we've kind of been building the single file and then we've been running it. But actually what will be kind of nice, and what you'll see also when we get to it later, when we add like databases and caching and stuff, is we don't only want to have our application running, we also want to have a database running that we're able to use with our application, and we probably also want to have a separate cache running that we want to use with our application. And so to be able to set up this whole system that we can reuse, and there's actually a lot of cool things that you can set up, and well, it's a deep topic to dive into, and we're obviously not going to cover everything, but we are going to go through the main points And as we get to it in further points down the road in this course, we're also going to touch this Docker Compose again and add components to it. For example, the database and the cache that I just mentioned about. But the point being that sometimes we just don't want to run one thing that's kind of isolated, but we want to run several things, and maybe those things are even connected. And so to make that process easy for us, we're going to use Docker Compose. And so we're going to start off by creating a new file here, and I'm going to call this Docker Compose, a docker-compose.yaml, like this. And if you have Docker installed, you should also have Docker Compose, so everything should already be set up for you. All right, so we're going to write some skeleton code first, and then we're going to explain what's going on. And essentially, the first thing that we're going to try to do is we're going to try to reproduce what we've had running with Docker, but now instead do it using Docker Compose. So we just want to get the same service up and running as a Docker container that we can still access through our web browser. So the first thing I need to define here is what version we're going to be using of the syntax. We're going to use here version 3. And then we're going to define the services that are running here. You can see I have the Docker plugin installed, so some of the stuff actually autofills. If you don't have it installed, then it won't. And if you still have that notification up here, then obviously the easiest way is just to hit install plugin, and it will install for you. But again, not really necessary. It just kind of helps with like autofilling and some stuff. But yeah. All right, so here we're going to define the different services that are running. So one of those services, for example, is going to be your application. So we're going to define one service. I'm going to give it the name app. We can call it whatever we want, but I'm going to give it the name app just to kind of be clear around what this is. And now in here, we're going to further define some of the things about it. So the first thing that I want to define is how can I build this application? What is the Docker file that we need to reference? In some cases, we may actually be referencing a Docker file that is, on Docker Hub. And in other cases, we want to reference a Docker file here that we have. So I'm going to have this build parameter, and I'm just going to point it to the current directory. So just using a single dot for that. And now the other thing that I want to do to get access to it, which we also did previously, is I'm going to define the port mappings. So in Docker, we use that -p. Here, we're going to have this be ports. And we can see here it already autofills it for me. But essentially, we're going to have a colon after here. We're going to go on a new line, and then we're going to have a dash, which indicates that this is going to be an array. So we can do multiple port mappings, but we're only going to use one. So a port mapping here is going to be, again, from port 8080 to port 8080, like this. And here we can see we're starting this on port 8080. So we want to make sure that our outside port is mapping to the correct inside port. Same thing like we covered when we ran the individual Docker file. And this is actually it, what we need to essentially reproduce what we had with our Docker build. So let's go ahead and spin this up. So the first thing that we need to do to get this running is we can use the docker-compose command, and then we're going to type in here up. And we're also going to add an additional flag, which is going to be --build. And so this means that we're going to spin up our container, but we're also going to build it first. So first build, then spin it up. So let's go ahead and run this. It's going to probably take just a little bit of time to build. Most of it should be cached. And let's see here. It's just still creating it. All right, so there we go. We have our container running, and if I click on this, then I should have access to it. So if we go to the docs page and try one of these endpoints, all right, there we go. Cool. So this is the default value that we have, and it's working. And if we want to take it back down, well, right now we're not running it in daemon mode. So if I just hit Control-C, it's actually going to stop it, which we can see if we go back here, refreshing, it is now down. But if we want to run it in daemon mode like we did for our Docker, so having it run in the background and not taking up the foreground here, I'm going to do the same thing, --build, and then I'm going to add a -d flag here. And run this one more time. Again, the whole thing should be cached, so it should go pretty quickly. And there we go. So now it's still running in the background. I can do docker ps to see that this is indeed running. And if I go and refresh, then again, we're running. And now if I want to take the service down, I can do docker compose down, which is going to just stop all of this. And again, if I refresh this, there we go, no longer running. All right, so far, so good, right? Pretty simple and pretty convenient. But so far, not that much difference to using the docker command, right? It's a little bit shorter because we can kind of do the build and the run step at the same time here, but still not so much shorter. So let's get into it a little bit more and see some of the other cool things that we can do. So one of the additional things that we can do, for example, is we can define this entry point variable. And here we're going to use the same syntax as we had in our command here. So I'm going to take this and I'm going to copy it over. But maybe what I actually want to do, I'm going to copy this over here, is when we're building our Docker file and we want to run it somewhere, we obviously don't want to run it with the -- reload flag because that's going to add a lot of overhead that we don't want. But when we're developing locally, it's really nice to have that flag because we can change things and we can make things, we can just develop quicker because we don't have to take down and restart our application. So ideally, we would be able to use this -- reload flag. And so if we define an entry point on our Docker Compose level, it's actually going to use this entry point or this command instead of whatever final command we have here. So in this case, if I run this again, Docker Compose up, and I build it, and I run it in daemon mode, we're going to see in a second, or well, actually not, so I'm going to take it down and run it not in daemon mode so that we can just see the output directly. Let's do that one more time. So here we see we started a reloader process. So that's because we have this reload flag now active. So we can see this works properly. Unfortunately, because we're running in a Docker container, so if I refresh this, this is working as intended. But if I try to make any changes, for example, going in here and maybe just updating the name of this endpoint, like just add something random here, we can see already it's not restarting, and if I refresh here, it's also not updating. But ideally, what I would want is I want to be able to have this thing running and be able to edit my code. And as I'm editing, just like we did when we ran it locally without Docker, I want to be able to have these updates kind of updating. And so the way that we're going to do that is let me take this down again. So we're going to add one extra component here, which is called a volume or volumes. And what the volumes allow us to do is they allow us to map essentially outside storages to places inside of our container. And volumes are extremely nice because they provide us a persistent method of storage. So our containers can go down, right? Like if we have our Docker thing running and we save things, ideally we do not want to save anything in our container because that container can shut down. And the way that our containers should be working is we should just be able to spin up a new one and it should have the exact same state as the previous one, right? Like it shouldn't evolve with time. And so if we want to store information, we're either going to send that out to databases somewhere, or if it is a database itself, it should store it in some sort of storage that even if the container goes down, the storage is still available. And so that's what this volume allows us to do. It allows us to map external places of storage to places in our Docker container. And we can use this for databases, which we'll see later, to kind of persist data as we spin up and down a database instance. But what we're actually going to use it for now is we're going to map our local state of our code into the state of the code in our Docker Compose. So what I'm going to do is I'm going to map our current directory to this place here in our Docker file. And this should not be here. So let's go over this one more time, then let's run it and see how it's working, and then maybe take another couple of moments to think about what's really going on here. But essentially what we did is in our Docker file here, we've created a new folder location, user src app, and essentially because we're copying over this app into this app folder in this path, this location that we're in, this folder, this directory, essentially kind of represents what we have here. We didn't copy over everything, but essentially, right, like that's what we have. We copied over the things that we needed. And so if I add the mapping here, for example, of our current location to that location in the Docker file, then actually, and I'll show you this now, and I'll add the -d flag again, because now we can have it running in the background. Now we're going to map this place inside of our Docker file to this place, which is currently on our local machine. And so let's see this in action. So if I refresh this, oh yeah, take this down. Okay, there we go. So now we still have, what we have here. Now let's go ahead and make a change. So I'm going to add an extra A here, save. I'm going to refresh the documentation. And now we can see our updates have actually been reflected. And so again, the reason that we were able to do that is because previously we were unable to access, after we've created our Docker image and we started up the container, we were unable to access its contents internally. But now we've created a mapping of this folder here to this folder here. And what we could also do is we could actually be more specific and just map, and I'm going to undo these changes here like this, and let's do Docker compose down, just so that we're starting from like a clean slate. We can be more specific and kind of map the application folder that we have here to the application that we have there. So because we're copying this over in our Docker file like this, which is going to be in this path, we're going to take a mapping of the app folder here to the location that we've copied the app over in our Docker file. So refresh this one more time. There we go. That's what we had. Now I'm going to update this one again here, save, refresh, and there we go. So again, volumes allow us to map these storages from inside our container to some sort of external storage. And this is really nice because in this way, we're also able to kind of save data outside, and if a container goes down, we can just connect it to the same persistent volume and we'll have access to the exact same data, which is obviously really nice if we have like databases running, for example. And yeah, just keep that in mind, that if you're running a Docker container and you're saving to like a local file, once that container goes down, that file is gone. So always, if you need anything, always save it somewhere outside of your container, because you won't really have very easy access to it inside the container, and once it goes down, it's gone. So just keeping that in mind. And yeah, this is again where volumes really help us out. Okay, so volumes are this is kind of what we have right now, which is essentially the application that we've had previously. And let me take it back down. Now we're able to do a lot more with this. So we have our current application, but something that we also want to do is we want to be able to like run our unit tests, for example. And ideally we would run that in the Docker container, because that's exactly the setup that we're going to have when it's running in production. Because that's the whole point of this, that we have this reproducible setup. So I'm going to create a new service. I'm going to call this app-test, just to indicate that this is a test version of our app. I'm going to take this here, and I'm just going to copy most of this over. And I'm not going to update the entry point. This doesn't really matter too much. And I also don't need a port mapping, because I don't actually want to do anything with our test container. And also, if I use this port mapping, then we're going to have a conflict, because we are already mapping our system port to this port inside the Docker container, and we can't remap the same port twice. So this will actually cause a problem, so we need to remove that anyway. And I'm going to now, instead of mapping the app just the app folder. I'm actually going to map this whole directory because if we go into our Docker file, you'll notice we're not actually copying over the test folder. But we still need to have access to that inside of our Docker container. So now when we run this, we will actually have two separate containers running. The first one is going to be our application that we're currently using with this / reload flag, which will allow us, because we're kind of mapping our folder here to that place inside the Docker container, to do development and, look at it in our web browser and be able to play around with it. This container here is essentially going to be responsible for just running unit tests against so that we can actually test our code. Okay. All right. So there are still some other things that we need to take care of, because if we go into our Docker file, we actually notice here we do not install any dev dependencies, and we need the dev dependencies to be able to run our unit tests. So now what we have to do is we have to update our Docker file so that the installation process that happens here is different depending on if we're in our application or if we're in the application that's just meant for running tests in. So let's do that first. Now what we need is some sort of way to indicate where we currently are. And now a great thing that you would usually do with this is using environment variables. Unfortunately, we don't have access to those inside of our Docker container, but we can provide build arguments. And the way that we can provide those is by, instead of just using this build syntax here, we can actually expand upon this. And I'm going to provide two more keywords. So the context is again going to be where our Docker file, or where we're going to run this thing out from the location, which is going to just be the current location. And then now here we can also provide build arguments. And again, we can provide this as an array or as a list, and we're going to provide the name, and then we're going to provide the value. So for example, I can call this name environment, make sure I'm spelling that correctly, I think I am, and the value here is going to be test. So I'm just going to make up a name, what I'm going to call environment, and this is going to be the value test. And now I need to do a similar thing up here because I don't want to have dev dependencies installed in our application, and so this one I'm going to call either dev, or maybe I'll call it local. So now what I want to do is I'm passing this build argument. Now I need to be able to get access to it inside of a Docker container, and then I want to update our run here so that if this environment variable here is test, I also want to install dev dependencies. Otherwise I do not. All right, so first things first, to get access to this build argument, I'm going to use this arg keyword, and then I'm going to put in the name of this variable here. This is now going to give us access to this argument inside of our Docker build here. All right, now what we need to do is update this statement to conditionally, and we're going to use an if statement for this, but we're going to use a bash if statement to conditionally install with dev dependencies if this environment value here is test. So to write an if statement in bash, and we're not going to get into too much detail here, really just kind of going through the bare bones to have enough to be able to do this, because most of the time you won't be needing more than this, and if you ever do, because you know how to write conditional statements in Python, you'll understand the logic and be able to transfer it to bash. You just need to look up the appropriate syntax. So our syntax is going to be if, and then open and close square brackets, and then here we're going to put if, and to access the environment variable in bash, we're going to need to put a $sign in front of it. So if, or the build argument, if the value of this build argument that we have access to because we define it up here, if this value is equal to the string test. Now a very important thing here is having spaces before or after and before we open and close these square brackets. Then I'm going to put a semicolon here. This is important because if we want to have more than one command on the same line in bash, we need to separate those by semicolons. Otherwise, we would be creating new lines, which would also serve that purpose. But because we were going to have most of this on the same line, I'm going to put a semicolon here. So if our environment is test, Then we want to install with dev dependencies. So then we want to do the same thing here, but with dev dependencies. Again, a colon, because this is all on one line. Now, because we're going to go over one line, because I don't want to have this thing like running into infinity to the right-hand side, but we can also see we have like margin suggestions here, and we don't want to go over this. So to continue something that is on the same line, and we're going to enter a line break that we can do with the backslash. And we're going to continue this on the next line, and then we're going to have our else statements. Another colon here, and then to end the if statement, we do fi, so the opposite of if. So let's go over this one more time. What did we do? We created a build argument that we're providing as we're building our image with this value here. We're then getting access to this build argument here, and we're accessing its value here. We're comparing it to the value test using a single equal sign here. Then we have a conditional statement. So if this value is test, then we're going to do this install statement, and we've added this minus minus dev to also install dev dependencies. Otherwise, we're just going to do our normal install, and then we have some special keyword stuff here, just, because that's kind of, that's the way that the bash if statement looks like. That's what you have to write it. All right. Okay, so let's start these up. We're not actually like running our tests yet, but we can if we wanted to. So if we wanted to, we could, for example, update our entry point here to instead be something like, pytest and tests. But we're going to look at a better way that we can do that in a second, because if we do it like this, then we'll only be running it once when we start it up, but ideally we'd be able to just execute it at will. All right, so I'm going to just run the build, not in daemon mode right now, so that we can see the full output. All right, so this time it's going to take a little bit longer because we've updated our statement here. And so now we are no longer going from cache, but instead we have to redo this thing, which actually includes installing components, getting it from online, downloading it, doing the installation process. So it's going to take a little bit longer, hopefully not too much longer, because everything else should still be cached. And yeah, we'll wait for that to finish. All right, so our build finally finished. Everything is starting up. So we can see here, this is our first container running, and this is our second one. And here we can actually see the output of the tests. We have 9 tests that have passed, and the other container is still running. So I'm just gonna, don't want that. Click down a link here somewhere. All right, so let's, take this down. All right, so we got that running. Excellent. Now the thing that we're gonna update is, instead of just running these tests once, instead what we're gonna learn to do is we're going to run these tests whenever we want to against our containers. So I'm going to build this, spin this up, build it again, run it in daemon mode. If no code has changed, you also don't need to rebuild it, which will obviously make the process go faster. So if we do it like this, it's just going to spin up the existing image that we have built for it already. And if we do add the build flag, then it's going to rebuild. And even if everything is cached, obviously it still takes a little bit longer. So now to run our tests against this testing container that we have here, we're going to use docker-compose, and then we're going to type in here exec. So we're going to execute something against something. Our target is going to be this app-test service that we have here. And what we're going to run, the command we're going to run is going to be pytest tests. So we're running pytest against our tests folder here. If I hit enter, and there we go. So we're running our tests, and now this is really nice because everything is running within a Docker container. Or in several Docker containers, we have 2 separate containers here running. One of them we can use for like local development, and we can make our changes. So let's just see this again. If I remove this, this should still be going away, and we have this mapping because of volumes. We have several containers running One of them is one that kind of simulates what we'll have in development production, except that we've overrid this flag to be reloading. This one, although we never copied over any of the test files here, because we don't want them in our final image, because we've used a volume mapping here, we actually still have access to all of that here, because the way this folder looks inside of our Docker image is now actually going to be represented by what we have here locally. And then we were able to use this docker compose exec command to run a command against a specific target, which is the name that we have here. And this is the command that we're going to run against it, which means whenever we make changes, we can also just make our changes here, update our tests here, and then when we want to run it, we can just execute the tests against it, and with that kind of run our unit tests, and everything is in a really nice, reproducible Docker environment, which is awesome. And yeah, with this setup, we can then, and we'll see, in the future, we can do a lot more stuff with it. We can, for example, add like environment variables by just having an extra keyword here. We can already see, we can fill in this stuff. We can add extra services, which is going to be like our databases and our cache, for example. Or if you're actually building multiple services that, maybe want to, contact each other, you can actually have all of those different services that you're building running at the same time, so you can test all of them as if they were, running live somewhere. And this really gives us a lot of power because we're able to just spin everything up, let it talk to each other, and be able to test in a very nice and reproducible manner. So yeah, Docker Compose, I hope you find it useful. And again, there are a lot more, like arguments here that we've looked at, or that we haven't looked at, that provide extra functionality. And if you ever need anything else, with Docker, then you can just look up, what is the variable name that I need to provide here, and how can I put that in? And you'll be able to set that in Docker Compose. And personally, I prefer this a lot more because our commands here are a lot shorter compared to having these longer like Docker commands. And again, we can define everything in these like YAML configuration files, which someone else can just take and run, whereas otherwise you'd have to send them your exact copy of what command you're running to like spin up your container from an image if you're like providing a lot of environment variables or something like that. Whereas with this Docker Compose YAML, we can have all of this pre-configured, and hopefully someone else should just be able to take all of this, spin it up, run the Docker Compose, and be able to have the exact same thing. And yeah, it just makes everything easier all around, because once you've reached this point, obviously it's a little bit of legwork to get here, but once you've reached this point, you're at a really nice place where you're able to have like reproducible things. What you have here is how it's going to be when you run it somewhere else. It's very easy to make changes, to add new things, and to keep everything like reproducible and testable and everything like that. So one quick more thing that I do want to show you is sometimes you may have, for example, multiple Docker Compose files. And essentially, I'm going to create a new directory here. I'm going to call testdc. And I'm going to make sure to take down my existing containers. And there we go. And then I'm just going to move this Docker Compose file here. So let's say we want to have different composes for different scenarios. If you ever need to have something like that, then what I can do is I can add a -f flag to reference where that is. So if I run this now, it's not going to work because it can't find a Docker Compose file. But if I add a -f flag here, I can point to my file, which is going to be in testdc/docker-compose.yaml. That is our file name. And then we can try to run it again, and bam, there we go, it works. So just kind of like a quick aside, in case you ever like run into something like that. Obviously, to take it down, we need to have the same syntax here to take it down. And yeah, so I'm gonna, I do not want that here. I would like this back here. So yeah, obviously, this is not as nice as just having it directly here, and that's exactly how I'm going to keep it. But just kind of as a quick aside, if you ever run into something like that, then that is how we can go about that too. But yeah, so that's Docker a lot of Docker Compose, and although we've done a lot of legwork to get here, now we've reached a really nice point where, again, we have very little commands that are very, like short and readable that allow us to build very complex systems and have them run in a way that's reproducible, which is just super nice because this can give you a lot of peace of mind to make sure that the way that things are running here is going to be the way that things are running elsewhere, which is really, really nice. So yeah, I know that some of the stuff can be a little bit like confusing when you look at it the first time. So just take some time to like play around with some of these things. Take some time to like play around with this volume to understand what it does. Take a look at each of the things that we did here. Maybe try to add like another build arg or change the naming here just to like see what happens, to make sure that you feel more comfortable with it. But over time, you will be feeling more comfortable with it. And also, again, it's because when we're building this stuff up, a lot of these things will end up looking similar for obvious reasons. So you'll generally be approaching it the same way. And most of the time you'll have like templates to work off of to have these like Docker files. And then you'll just have to kind of adapt what you're copying over, and how you're doing the installation, et cetera, et cetera. But a lot of this is actually like boilerplate template stuff, that you can reuse. And obviously, we want to go through it in detail once, just to understand properly like what is going on, so that if you read it or you need to make changes or additions, you know where to look, you know what to look for. But yeah, most of the time, you'll have like a template to work off of. You have a template now. You may have a template in your organization. You can find templates online that can help you reach this final result a lot faster. All right, so we've gone a long way and we've actually managed to reach a point which is, pretty nice about not having to write that much stuff to get things up and running. But over time, you'll probably, even with this, get frustrated having to write over and over the same things. And there are more ways that we can use to shorten this, to essentially have shortcuts for commands that we're executing regularly. Now, this will work on a Mac and a Linux. I think for Windows, you will need to do some extra setup to have these make files work, which is what we'll look at now. But generally speaking, if you end up working in an organization somewhere, it's unlikely that you'll be working in Windows. Not that it's impossible to, it's just much more likely that you'll be working on like a Mac or a Linux. So yeah, just kind of keeping that in mind. We'll go over this now because it's common to either create makefiles for yourself or to see them in another repository, because as we'll see in a second, they will make your life a lot easier. Again, for Windows, there is some other stuff that you need to install to actually have these commands work. It's not super important to like get this running. So, just kind of be aware of this, that these things exist and this is how we can run them. And, you can create them if you want to, or you can leave them out because they're just kind of nice things to just make short syntaxes even shorter. But yeah, anyway. All right, so let's create a new file here that we're going to call a make file, like this. And in this make file, we're now going to define a series of commands that are going to allow us to essentially, what we had here, like the Docker compose up -- build, like -d, just so that we don't have to write this out every single time. We're going to make a shortcut that's going to run this for us. Now, one very important thing here is if you're in PyCharm, like I am here, well, in this file, we'll want to go to the bottom and click on this 4 spaces and configure indents for plain text and use tab character instead. Because the make file has a very, very specific difference between 4 spaces and a tab, whereas in other cases, like in Python, for example, it doesn't really make that much of a difference, so it's fine to use it like this. But in PyCharm, you'll find it down here. If you're using Visual Code, if you're not using PyCharm, but Visual Code or anything else, you'll find it in like a similar probably location. But generally, like if you run into issues that is saying that there's some like missing separator or whatever, very likely the issue that you're running into is, well, 1, you forgot to put a colon, which also happens. But 2, the other very common issue is that you're using spaces instead of tabs. Okay, and I'll show you also in a second a quick way to see that. And actually, let me turn that off for that just to show you how that would look like. All right, so the first thing though, what we want to do is we're going to define a command here, which is, I'm just going to call start because it's short and I like it, but you can call it whatever, like run, spin up, whatever. I'm going to call it start. And when we run this command, what we want to have is this minus the build part. So like this. Now you'll notice that I'm using spaces right now because if I go back here, you'll notice it goes back 4 times. So these are spaces. And if I change this from 4 spaces to using a tab character instead, delete this and press tab again, now when I'm going left and right, it skips. So this is the tab character. Very big difference. If you're using spaces here, you're going to run into problems and it's frustrating. All right, so we have start. Another thing that we use very commonly is start with build. So I'm going to call that start underscore build. And here I'm going to just put this command like this. Another thing that we want to do is take it down. So you can either use takedown, but that's a long word. Stop is an easier word. And we're going to do docker compose down like this. And another thing that we probably want to do regularly is run our unit tests. We can call it unit tests or unit test. I'll use plural because we're probably running multiple tests, and the command that we're going to run here is going to be that command that we saw previously. So docker compose exec -t, and it's going to be app.test, which is against this container here. And, oops, and the command that we're running is pytest tests like this. Okay, so these are 4 commands that we'll use pretty regularly. And here from this we have our makefile. There's one thing that we want to add at the top, which is we want to provide a list of phonies, which essentially tells the makefile that these are commands, and if we ever have files of these names, that when we use this with the make command, which we'll see in a second, that it should treat these as commands. So we're going to put all these commands here that we want to use, which is going to be start. Then we're going to have start underscore build. We have stop, and we have unit tests. All right. So let me see if anything is running. It is. So I'm going to do, well, let's use our make command. So I have these 2 running still from last time. And what I'm going to do is now I'm going to type make stop, which is going to run this command here. I'm going to hit enter. And we can see it's executing this command and it's taking everything down. We can do make start to run this, and it's going to bring things back up for us. So see here, if I refresh, it is. Hold on one second. There we go. All right, and let's take it back down, make stop. And there we go. Now if I refresh, there we go. So no longer running. One thing to note, if you don't want to see these commands, we can add @ symbols in front of everything. And now when we do make stop, or I already ran that, sorry, make start. Now we're not going to see that command printed out. So that's just, a little bit to just get less stuff even here. If we want to run our unit tests, make unit tests, which is going to run it against our testing application here, just running this command like we've seen previously. Bam, there we go. Another command that we maybe want to do is check our typing, so we can do check typing. And I'm going to run this command here, or running against our test container, I'm going to run mypy like this, like we did previously, and then we can do check typing, add that to our phony, and we'll say make check typing, which should now check the typing against our testing container here. While this is running, let's make some shorthands, because sometimes, maybe we want to run like unit tests here in our container, but in some cases, if your containers, your Docker Compose gets very large and you don't want to have all these things running, then something that you could do instead is maybe also run things locally. So maybe sometimes you just don't want to spin up a container because maybe also the container just takes a lot. So what we can do instead is also just add kind of aliases for this and then reuse them. So for example, let's create a unit tests alias. And this here is going to be, oh, sorry, this should be an equal. It's going to be pytest tests, like this. And now if we want to refer to like pytest tests, we can instead refer to this alias by using a dollar symbol here and then open and close parentheses around it. And so then we can have our make unit tests like we had previously, like this. And we can also have another one, which is going to be unit tests local, like this, which is just going to run our unit tests. And this is probably going to fail because I'm not in my virtual environment right now, but let's see. Yeah. So let's go ahead and go pipenv shell. And let's do make unit tests local again. I'm going to open a new terminal here. Got myself into a weird state. Make unit tests local. All right, so there we go. So yeah, so this is a nice way how, like we can reuse this. And similar things, and especially if our commands get longer, sometimes it's also you have like commands that go over multiple lines, which again, we can separate like using line breaks like this. For example, if this were to go, over to a new line, I could instead separate it like that. But if we do have longer commands, then sometimes it's also nicer to just have an alias for them up here that we can reference down here, just so that this stuff becomes more readable and doesn't become so clogged up. And yeah, that's kind of what we're doing for typing. Or sorry, not for typing, this is what we can do for our make files here, which again just adds a little bit more simplicity, makes our commands a little bit shorter. I can do make stop to take down our containers instead of docker compose down. If I want to build, I do make start build, just shortens it again just a little bit. And yeah, that kind of wraps up this. There's one more thing that I wanted to mention, not related to our make files, which is just going to be looking at logs. Something that I find quite easy to do when we have like a Docker container is running is if I actually go into our Docker desktop app here, you can click into these and see the logs directly here. But just kind of as a quick aside, because we haven't really done this, is if you do want to look at logs and you want to do this over the terminal, then there's the docker logs command. So if we reference a container ID, for example, our main application, we want to look at the logs, we can look at it like this. If I want to look into our testing application and just put that command in here, so there we go. So obviously we don't have a lot of logs right now, but just in case you ever want to do this and you don't want to use Docker Desktop for this, then you can also do this over the command line. Since we've been doing a lot of stuff for the command line, and sometimes this can also just be easier for that process. So yeah, hopefully you'll also find having these make files useful. You'll probably see them too in being used in whatever organization you will join, that they'll have like make files there to just have a list of commands that do a certain process. It just makes it all very easy to just have make files for this, so that it's even easier to run and you don't need to tell someone else what the command is. They can just run the make command, and very simple to write, and again, a very nice way to kind of get these reproducible things. And yeah, obviously they make our life a lot nicer too, because we have to write even less.